In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice? A flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade.
All right, we're back. We're live. Sorry about the interruption. We had a brief Discord attack, so had to deal with that. And now we're back. We're going to pick up where we left off. Cassandra was laying out the agreed upon framework for two debate opponents and how they should go about introducing evidence and stuff so that they could, stay on topic to the subject matter. Bennett, if you want to pick it up from there.
Yeah. Just want to note, we're in the stage room with 13 in the audience, and it says Alan and 10 others, so that means there's 2 unaccounted for. Whatever that means.
Yep, it'll be fine.
All right. Okay. Okay, yeah, I covered the discovery process where
if you
each
would,
side,
if you want to, you can just like get a fresh start on it, because I had to do a full restart on it.
okay, all right. All right, so I think a good idea is to present some general ideas. What is the purpose of a debate? What is the intent? How can you measure what whether your performance is improving or not? One suggestion was the discovery process used in trials, where both sides are required pre-trial to submit what evidence they will use in the trial so that there are no surprises and there is no irrelevant proof that is presented. And this counts only for the introduction. If the cross-examination begins, you can introduce any kind of documents that are acceptable to the judge who rules on whether it's relevant or not. So if you did this process in a debate, you would submit the documents, which could be just graphics. It could be a link to a document, whatever you're actually going to present as evidence in the debate. Once that begins, then you have to agree mutually on any new evidence as to whether it's relevant or not. But I think it's a good idea to try this because I saw that it would have been helpful in this relativity ether debate.
Very helpful.
I do require some background from the other side as to what kind of philosophy they accept. For example, if someone said that they were an agnostic as far as science is concerned, then that would be a showstopper, because if you believe that there's truth, but you say that you can't know what it is, there's no sense in debating. I also would say that about a nihilist or about an idealist who thinks that the world only exists in the mind, that there's no real objective reality. But that's the whole basis of science. My philosophy is realism, and so that's what I would accept as a ground rule for starting a debate. Another rule I have is show-stopping. Whenever there's a contradiction in what's being discussed, and what should be discussed is the null hypothesis. That is, whether the null hypothesis is true or false is the whole idea of the debate. But the showstopper should be employed whenever you have a contradiction in what the other side proposes, because once you have a contradiction, there's no sense in proceeding. It's like a KO in a boxing match, you've already shown that the evidence presented is false, and there's no reason to proceed. Again, most of the times debates continue even if contradictions are exposed, but that's up to the debaters. I learned my rules for debates in high school, but I haven't used them. There's been no reason for a debate. I've had discussions on the internet, and yeah, you might call them informal debates, where we take a topic, a scientific uh, topic, and debate it back and forth, but nothing formal. I do think it's interesting that the Russians use debates very heavily. Because of the size of the country, they usually use Zoom debates, remote connections. What we use in the West are peer reviews. You know what peer reviews really mean? It means that you're having censorship review. It's the way it works, guys. You have a paper that you want to present, a formal journal, in a science journal. Usually you are required to submit it to a panel of your equals. But your equals often are people who have a contradictory theory, or they have some axe to grind for some other reason about why they don't approve of your theory. Peer review then turns out to be a way of blocking dissident information. So I like the Russian method, which emphasizes debates. Before papers are presented in Russian journals, they're exposed to public debates, and the evidence on both sides is presented, and then paper is presented. So that's certainly that I would recommend, but again, it's something that requires the consent of the Western science group. And all I can point to is the success, I think, of the Russian debates. The null hypothesis was missing in this debate. To say that it's ether versus relativity is very vague. The null hypothesis is something that can be tested true or false. So I would suggest that it should have been stated let's see, Galilean relativity leads to a better measure of reality than ether. And then, of course, you'd have to define what kind of ether. There is the ether of Lorentz, which is solid, rigid. And then there's the ether that we discuss for the most part, ether dynamics, in which ether is considered as a invisible fluid, which forms the basis for all of the motion that is observed in the material world. So you need the null hypothesis, and you need, in this debate, you need a definition of what kind of relativity are you talking about? Is it Galilean? Is it special relativity? Is it general relativity? And on the ether side, are you talking about Lorentz, rigid ether, or are you talking about ether vortices and winds, ether dynamics? In both cases, that wasn't defined for this debate, and it should have been. Practice debates is a good idea, because if you get someone who can serve as the opponent, you can get an idea of what you would present and how it be attacked. One thing I noticed was you were using a tag team approach. You might want to consider whether that's better than or worse than just a single one on each side. With the tag team, you have the benefit of more experience, wider view, but you also may have some agreements with what your tag team partner presents, and it's awkward to correct your own partner for obvious reasons. Okay, as far as measuring the performance, if you make changes in your debate strategy, how can you measure the performance? Well, one way is to see if your viewership increases and the comments. I was very surprised to see how many viewers or how many views you got, 4,300 in the 2 days since the debate. To me, that's pretty impressive considering what my channel draws. And the comments were about 100. So in the future debates, you might look and see, am I getting more views than 4,300? Am I getting more comments than 100? Of course, that's a very broad standard, I should say. Okay, I don't want to get into the debates without getting feedback about what I just talked about.
No,
Yeah, that's fair.
I really like what you proposed, and yeah, moving forward, I would love to take debates to that level of agreement, so that you both have a chance to attack each other's arguments and stuff like that. I think that's what's been missing in the debate scene, and I think moving forward that'll be the new standard. You know,
Although both of us published our pretty much positions on our databases well in advance without
well,
mean-
to be fair though, that's different than being like, okay, Mord, here's what I'm going to use to argue, and here's my null and all that, right? Like Bennett was saying, because otherwise you're just kind of all over the place, you know.
Yep.
So
Yeah, I would focus on the just the description of the experiment. Just name what experiment you're going to do. Michelson-Morley. Okay, that's a generally known experiment. You don't have to reveal how you're going to use it. You don't do that in a trial when
right,
you present evidence, right? In the discovery part. So it's just so that you're not using a machine gun approach where you are using 10 experiments and rushing through them all, trying to get a point. Remember, the audience is interested in the topic, otherwise they wouldn't be listening, all right? But they don't have enough knowledge. They're trying to get knowledge from you. The simpler you can make it, the more complex, the more points you get with the audience, because they understand a simple approach where you use analogies or you simplify the argument as simple as you can make it, and that's how you win points with the audience or the judge, if there is a judge. I don't know.
yeah, there's typically not a judge per se, but yeah, the point about making sure that it's relatable to the audience is definitely should be prioritized in it. And in this debate particular, had no regard for it.
I've noticed that you guys are very skilled at flat Earth. Definitely, you definitely have the ability to interpret experiments in your favor, experiments which are often presented by the globalist side as proof of their globalism. You're very adept at that, but now you're delving into new subjects, more general subjects, and you need to build up, of course, your background, your knowledge of both what mainstream thinks and also of what the ether theory would predict. And again, keep it simple, just almost like these presentations that I gave where I didn't go into anything deeply unless someone asked, but I just presented what could be summarized on at least just one page of a slide.
Dr. Cassandra, not to, or sorry, Dr. Cassandra, Dr. Bennett, if you don't mind me asking, Omnivore had a question on my server. In the I love everything you said in terms of format, this idea of pre-debate discovery, everything you just said, I totally agree with. One thing that I think is interesting would be if there's a difference of interpretation between the mainstream view of an experiment and how it would be interpreted by, let's say, an alternative theorist. How would we handle that during the discovery phase? Like, particularly with regards to things like Michelson, Morley, and Dayton Miller, right?
Well, hopefully you can make it objective, not subjective, by appealing to the experiment itself and logic. Okay, whatever side you're taking in interpreting the experiment should be accepted in general. It's like saying, I'm going to prove the mathematical theorem and I'm going to use 1 + 1 = 2. Okay, everyone accepts that. Right? So you need to look for something that isn't controversial. Whether that can be done is, it depends on the topic. So I don't really have a way to resolve that except to look for something that is generally accepted as true.
Okay,
I agree with your advice. I think it was good advice.
Okay.
And
All right.
also the part about alternative interpretations. The judge and or moderator needs to be sure to be able to disallow all or nothing fallacies, because that does come up quite a bit in instances like these where you both are pointing to the same experiment or the same source, but coming up with different interpretations, and one side may tell the other, oh, you're not allowed to have that interpretation because the author said nothing about that in their paper, which is an all or
Yeah.
nothing fallacy.
A good example of that would be the fact that I was surprised that the experiments that were presented by the relativity folks used the experiments, many of the experiments, that I would have presented as proof of the ether side being correct. And when I heard the presentations, I learned that what the relativity people were presenting was assuming that the ether model was the Lorentz rigid ether, the absolute ether frame. And the experiments, I agree, that were chosen refute the ether as a solid. They do not refute ether dynamics, ether modeled as a wind or vortex, whatever you want to, however you want to describe it. And so that should have been a point of attack to point out that the experiments being promoted by the relativity side were accepted by the ether side because they were using a model. I guess you would call it a red herring fallacy. They're using a definition of ether which the ether side should not have been accepting, namely that ether only exists solid, rigid, Lorentz type ether. Right?
Yeah, absolutely. I didn't even think of that. As you're saying it, it's like blowing my mind. Like the distinction between the rigid ether theory and ether dynamics.
Remember, we used Tchaikovsky, right? What's the name of his book?
That's
Ether
Tchaikovsky.
Dynamics.
Ether dynamics. Yep.
Or Hildegard, right? All of Hildegard was ether wind.
Yep.
So that would have been the response to the claim that the ether was false because they were using a solid ether model. That would have been effective.
Dr. Bennett, do you mind if I ask a question? So I just had a question with something that's not clear to me, and perhaps this is just my ignorance about the alpha model, but maybe some of the audience might also benefit from this. I don't understand the existence of the ether as something that moves and how that is congruent with the notion of an absolute lab frame, how those two ideas fit together. Is that something, do you mind like quick, I know that's kind of a big question, but is that something you could explain really quick?
Sure, that's a category error. What you're comparing are two things in different categories. Absolute lab frame is a reference to the observer, okay? Not to what is being observed. The ether is being observed. When you say absolute lab frame, you mean that where the observer is situated. And an absolute lab frame means that that's the only frame that can be used in physics, as opposed to a frame in kinematics, where you have relatively moving coordinate systems. Okay, so ether and absolute lab frame are not in the same category. Understood?
Yeah, that's just a little confusing to me because maybe this is just my lack of education in physics, but my understanding was the whole purpose of relativity was to make congruent, at least in the special theory, was to make coherent the fact that the speed of light would affect the laws of physics as was discovered in the work of Lorentz, as it pertains to the Maxwell equations. And so I don't understand how within the framework of the rigid Lorentz ether that you mentioned, it makes sense to me that there can be an absolute frame of reference against which we can measure things. But within an alpha model, let's say, with an absolute lab frame plus an ether wind, it's not clear to me how that resolves the anisotropy of the speed of light problem. But perhaps I'm just not understanding something.
Well, if you have ether that is if the speed of light is measured with respect to the observer, but with respect to the underlying ether, then the speed of light is speed c plus the speed of the underlying ether, v. And that's exactly what was discovered experimentally by Sagnac, 1913, Dufour-Prunier in the 1940s, I think.
Yep. 42.
And then a linear version, Ruya and Wang in 2005. All of those showed that the speed of light is c plus v, where v represents the ether that is dragged by the moving mass. Just as moving mass drags air, or a boat drags water along with it, we can prove that light is affected by the motion of the ether underneath it, or through which it moves, by experiments like Sagnac. So that's what we're saying when we say there's an absolute lab frame. It refers to not to measurements, to predictions that are made according to the laws of physics. So Newton's bucket showed that if Newton observes the bucket and applies the centrifugal force law, he correctly predicts that a vortex will form. If someone on the bucket, however, looks at the water, and the water is co-rotating with the bucket, so it's at rest in the bucket frame, the guy in the bucket will say that the water should be flat because he sees no rotation. And yet, the bucket viewer will see a curved surface. So that means that the Earth, Morty, is an absolute reference frame, because if I take the Newton's bucket and I move it anywhere in the universe, the same thing will be true. The only thing that affects the centrifugal force are three things: the mass of the water in the bucket, the radius of the bucket, and what else? Oh, the speed of rotation, which is equivalent to the period, the time that it takes for the water to rotate once. Now, if all three of those are present, none of them include the distance from Earth to the bucket. So I can move the bucket anywhere in the universe, and the same thing is true. Only the Earth reference frame will predict correctly what the bucket does. So only in dynamics is the absolute lab frame, which is the Earth, identified. In kinematics, it's the relativity principle is true. Yeah, relative motion makes it independent of the observer. And so you can use any reference frame when you're doing measurements. Making predictions, you can only use the lab frame. So in a nutshell, that's what the predictions of the alpha model are.
Okay, that makes sense. Thanks for clarifying that. And I don't mean to like derail things too far from the presentation. I did have one more question, but I'll defer to the room if we want to keep moving forward to get to the debate, but up to you guys. Maybe we could talk more at the end, whatever you think.
Is the topic for your question going to be covered in what we're about to review?
Yeah, I think it might come up. It was related to
Let's handle it then.
Okay, go for it.
Okay, anything else? I think I didn't mention the real purpose of the debate is what? Truth, objective truth. And you should be satisfied, even if you, quote, lose a debate. You've at least learned what the defects in your own theory are. You've learned perhaps what the positive elements are of your opponent, and you can move on in what we hope is a search for truth, not a personality contest, not a chance for ego trips. It's ideally a search, science, objective science truth to be discovered. So with that in mind, if you want to look at any of the particular parts of the debate, I've made some notes, but if it depends, Alan and Toby, how you want to proceed.
We can go over the notes, or we can go over your notes. I have it downloaded, or I downloaded the debate. So if you wanted me to skip to a specific time or whatever to like set a preface, we can watch what unfolded, and then you can commentate on it or whatever, however you want to do it. And then we could do questions and stuff. I know Mordwan's probably got a bunch of questions for you.
Could I suggest something, Alan?
Yeah, sure.
Perhaps we just start with the opening statements, and we could analyze from the perspective of what Dr. Bennett had recommended with regards to discovery, what should and should not have been admissible. Maybe that could get into the discussion of the showstopper and contradiction, because I think we're going to hit that very quickly. and then perhaps from there we could start going into Bennett's notes and then seeing if there's any moments of debate that align to those. But I'm not trying to run the stream, so I was just curious what your thoughts were on that.
No, you're good. I like it. You in for that, Bennett?
Yeah, that's
Awesome.
that sounds fine.
I mean,
There's just
Cassander. Sorry, I didn't mean to
one-
use your government name.
there's one problem. My screen only shows basically a blank screen with joined
Yeah,
voice.
looks like Alan's stream is not up currently, right? That's what I'm seeing too.
It should be up. Oh, I shared my wow. 1 second.
Spinny blocks, itis.
It should just be my full screen. All right, how about meow?
It looks fine to me.
The left edge is cut off a little bit.
You're a left edge.
Was it cut off on Jaren? I don't know. I can't tell.
No, it looks fine to me.
Maybe I need to leave and come back then because it's just spinning for me.
Yeah, same here.
Well, the left side of your PowerPoint presentation or whatever it is.
No, he's in 1080p and 60, so people who get Satelloon internet can't see. That's all it's happening.
Oh,
I
1
usually
second.
don't have problems.
1
So
second. I'll put it on 30. I'll put it on 30. 1 sec. I got you.
I bet this immediately fixes all the problems.
Yeah, there's a good chance. All right, how are we looking now, lads?
It's still at 1080p 60 to me, so maybe it's just frozen.
Yeah, it should be
Yeah,
on.
you might have to quit it and restart it or something. I don't know.
I think you need to restream. Yeah.
Okay. All right, lads. How are we looking now?
Great.
Fantastic.
Do you guys see where it says "the" on the true nature of ether? I can't see the word.
Oh, it
"the"
is
yet.
cut off on the left. Yeah.
Oh,
Yeah.
yeah, that's a Jaren issue or Peter issue.
Okay.
So like whatever
That's
he.
just the way the stream is.
Did
Gotcha.
Peter present a cropped image?
Oh no, at some point Jaren fixes it. It was Jaren. It's all good.
Okay. Sorry.
I'm still not seeing it. I'm going to duck back out and in and see if that fixes it.
Yeah, I'm rocking 3 dots again now.
All right, boys. I'm gonna put it in for 720 pizzle.
Yep. Yeah. Were you still on something crazy though?
No, it was on 1080 30.
That's kind of crazy.
I mean, is it?
I mean, not for me. No, it shouldn't be.
SOP, dog. All right, we're at 720 30.
Oh my God.
Should be better.
Okay.
All right, can you guys hear it?
All right. Our position is
I can.
All right, cool. Just making sure the audio is going through.
that the true ether cosmology was
You
established
hear
by
it,
the famous
Toby?
experiments of
I forgot
Yeah,
how
I'll be
gay
right
it
back.
was. I forgot how gay your guy opening position was when you were like pretending to amalgamate ether. My God, it's all coming back to me now.
See if we
Why
can
is
get-
it not working for me? It's weird.
the late 19th century,
I hear it,
Which
but don't
led-
see it.
Me too. I'm in exactly where Toby is.
What the? All right. Can anyone else see the video?
Yeah, I can boot up. I can get Morley in here.
Yeah, get more. Thank you. We're gonna
Let me just take me a couple minutes.
get Edward Morley in here real quick to stream for us.
Morley.
Summon an AI assistant when you need help.
Can you drop the link to it in the chat if you didn't already?
Absolutely.
What's that? Thank you.
In the main chat.
All right.
Okay. And then we go here. All right.
Shout out
Yes,
to
that's
Edward
much
Morley.
better.
Hey, success.
Hello, sir.
Hello, Sea Lion Prime, also known as Mordwand. I'm here representing all sea lions across the world, but especially those that will be witness to the final experiment in
I wasn't
Antarctica.
even listening. I missed this completely.
Yes, those sea lions. And we've got myself, Jaron from Jaronism. I'll be moderating.
Here, you could
completely
skip
down the middle
forward
as
a little
always.
bit.
And we've got Alan on this side over here. Alan, welcome to the show. Welcome back.
Hola, senor.
¿Cómo estás? That's all I know.
Nice. Yeah, I'm representing ether cosmology. I'll be taking the position that the ether is the positive position and arguing against relativity.
Beautiful. And we've got your partner, Shane St. Pierre. Now, Shane, what's up?
What's up, Jaron? Welcome. Good to be back, everyone, man.
Thank you.
Good to see our opponents here. Hopefully we'll have a delightful.
So sorry, I guess should I skip ahead to opening
Yes.
statements here?
Yes, please. Yes.
Yeah. Okay, let's see here.
Is that the true ether
Did he echo
Oh,
for
right.
the whole time? That
Position?
sucks, man.
our
I don't think so.
we represent
Did
globe
Peter
gangsters.
just have the echo the whole? It's not real, or it just doesn't last.
I haven't heard that
I don't
echo
know.
before.
Yeah, it's a phantom echo on your end.
Oh, it's me. My bad.
You guys.
But
are
today
you
we'll try to
gaslighting my
build some
soul,
bridges
Alan?
with our ether cosmology community. So I will present our position. All right. Our position is that the true ether cosmology was established by the famous experiments of the late 19th century, which led to its current description via the general theory of relativity. That's our position, and we will defend it all the way.
Do you think we can
The
do
true
like
nature of
1.5?
ether since 1920s is ether is a metaphysical background that acts as a medium or substrate for matter and electromagnetic phenomena. It is a four-dimensional substrate whose states cannot be ordered by time alone. We cannot observe simultaneous states at different locations in the ether. Its structure is influenced by the presence of matter, and radiation, and movement of matter and radiation occurs within or over ether, and it's affected by its local state. A renowned 21st century ether cosmologist summarized this as follows. Ether is an immaterial background medium of pure potential. It cannot be quantified or measured intrinsically. What we know about ether when no matter is present or locally is that it has these properties shown on the screen. When we observe ether behavior, we conclude that relative motion is rotation of ether. For all observers, ether rotates, and they all observe time dilation and length contraction in the relatively moving frame. The objects themselves do not shrink in any of the frames. It's the function of the ether rotation that causes the perceived length contraction and time dilation. We do observe this in nature. For example, a lot of muons get produced in the atmosphere, around 1 million of them, let's say, per area. We observe 49,000 of them reaching the Earth. This is impossible due to the extremely short lifetime of a muon. The only way we can explain it by explaining it via time dilation and length contraction. Here's the result of such a measurement, where we observe 49,000 muons out of 1 million reaching the ground. From the point of view of a muon, what happens here is that the length, the distance, shortens from 10 to 2 kilometers. But from a point of view of the observer on the Earth, it is the time as perceived at the moving muon that lengthens. This is the only explanation of that observable phenomenon in nature. When matter is present, ether is described as follows. On the left, we see the distribution, the shape of the ether. which influences the motion of matter and radiation. On the right, we see the distribution of matter in a given location. This is what we know about ether today. This can be easily measured, even by amateurs. This dad left a few atomic clocks at home, synchronized them with a few more atomic clocks, and took them on a mountain. Because he was in a different location of ether, those clocks ran differently, and he was able to measure them. In laboratory settings, we can measure time dilation, the difference in elapsed time, between atomic clocks at distances as short as 1 meter or 3 feet. Light propagation is also distorted by local shape of ether. On the left, you see an observed galaxy, the blue ring, and the light originating from that galaxy is deformed by the ether's shape surrounding
I don't know if I have this in me, guys.
yellow glowing object.
To just rewatch all this.
On the right, you see a chart
Well, I
showing
think
how many papers
we're almost through
confirming
the
this
intro here. I
effect
think we're doing
in
opening statements.
astronomy have been published in recent years.
Like, I just remembered I didn't listen even during this.
Furthermore, we know that ether can wave itself as a medium. When dramatic cosmic events occur, they can affect the shape of the ether, and that disruption propagates through space. We have devices such as LIGO that have successfully measured such waves in ether many
Can we
times.
do 125?
Or like 6, but did he say ether
I
waves
conclude by
itself?
saying that general relativity is an empirically verified description of the true ether cosmology. And I yield the remainder of my time to my good friend Sealand Prime.
Perfectly audible.
All right, Sealand, go ahead. You got 5 minutes and 5 seconds.
Peter, you'll need to stop sharing so that I can share. Okay. So.
Oh, yo, pause real quick. Yo, Bennett, did you have any, or Cassandra, did you have anything you wanted to comment on his opening statement?
Yeah, it's a few things. Ether is not four-dimensional. Ether exists in three-dimensional space. The fourth dimension is an Einstein fantasy. So that's one of the things I would have challenged is definition of a four-dimensional ether. Oh, let's see. Ether rotation, that I didn't understand.
Yeah.
The rotation of ether it's supposed to explain time dilation and length contraction.
So that's Peter's doing word salad to just say ridiculous stuff because he accuses that's what he says we do. So he'll occasionally say some nonsensical thing, and if you don't catch it and call it out, you just get stuck with it. So yeah, his argument about ether rotation is just a nonsense mechanism that he's proposing because he thinks that what we say is nonsense. That's how he argues it. Just trolling when he says that it doesn't mean anything. I didn't call it out. I fucking forgot about it. There was other shit.
Yeah, we didn't address anything that he said. I just remembered that too because it was all nonsense. We both immediately dismissed it, but from the audience perspective, we didn't address it at all.
Right, you got to point that out. Later on, he talks about an ether wave, but if they're claiming that the ether is the Lorentz ether, there are no waves. It's a solid, rigid structure that underlies all of the motion in the real world. So there's a conflict between what he said at the end, the ether wave, and the model that was presented at the beginning, that the ether is a rigid structure in space. Now the muon experiment, that's a classic experiment that is used by mainstream to try and convince the world that time dilation is exhibited in that experiment. There is also a standard reply, and I'll go through that quickly. It's not too difficult. Peter indicates that the measurements that are made are, number one, the decay rate of muons in the laboratory. So that's basically at rest. They're basically at rest because the muons in the upper atmosphere where they're being measured are traveling in cosmic rays that are like 0.99 or 0.98 of the speed of light. So the muons, when they decay on Earth, are considered to be at rest compared to muons in the cosmic rays. All right, so that decay rate is measured, and also the flux of the muons through a square meter. That is the rate at which muons pass through a standard area. It depends on your measurement system. Could be square feet, could be square meters, square centimeters, whatever it is. And the flux is measured in two places, at on the ground and at altitude. Now, what's missing is the measurement of the time decay of the muons at the altitude h at which the decay is being claimed. That's missing. It is assumed by Peter and by other mainstream opponents that it is the same decay rate as on the ground. But was it measured? No. So they assume that time must have changed in order to account for the difference in the muon rate between altitude and the ground. But this is a false assumption because there was no actual measurement of the decay rate or the half-life of the muons at the altitude of where the cosmic rays are decaying. So the answer to the muon experiment is that time delay is not proven by this experiment because no measurements were made of the muon decay at the altitude claimed. If it were the same as on the ground, then time delay would be valid, but no such measurement was made. That's it.
As a follow-up question to that, what mechanism would cause it within any sort of standard physics would account for a differential rate of muon decay at a higher altitude? That's not clear to me.
Flow of ether through the particles.
Through the particles.
The flow of the muons.
But by what mechanism does ether change the decay rate?
Well, that's something to be discovered. But is it an experimental fact or not that the ether produces the change in decay rate? Consider more the particle accelerators. Suppose you're accelerating muons to high speeds. The same claim is being made in the accelerators as is being made in this muon altitude test. Namely, when the particle is accelerated, there is a time delay, and they also claim a change in mass. But was the muon decay measured when it was at the point of collision or measurement in the particle collider? No. That's assumed to be the same as it was when the muon was at rest.
Yeah,
exactly what the mechanism is. Yeah, what the mechanism is yet to be defined, but it definitely is a fallacy to claim that it's the same when it wasn't measured.
Have we measured an appreciable Aether wind at the altitudes at which the muons are created? Presuming that they're created by cosmic rays, as the mainstream theory suggests.
Yeah, the ether has been observed. Yeah, we'd have to get into the Hildegard.
Okay,
the Hildegard model predicts why there is a geostationary satellite. There are two different ether winds, one which controls the motion of the ether around the Earth, not around the Earth, that controls the motion of the moon. Another one controls the motion of the sun. They're in opposite directions to the firmament's rotation, that is, the rotation of the stars. It is at this geostationary distance that the two ethers combine in their opposite direction to the rotation of the stars to produce zero rotation. So that's why a satellite hangs over a location on Earth without moving, because at that location, the ether's motion cancels out. So that's one instance of the existence of the ether. Another example would be the GPS satellites. Definitely, ether wind is shown to be dependent on altitude, because the Sagnac correction depends on the altitude of the satellite, and that shows that the ether wind increases with distance from the Earth.
So the Sagnac effect in that context, could you describe to me one thing? This is would have to be the generalized Sagnac effect as discovered by Wang, right? Because presumably, if we were assuming a standard Sagnac effect based on the rotation of the Earth and the receiver relative to the satellite, that would be not explainable within this model. So this would presume that the linear Sagnac effect occurs, and also that what's observed at the satellites, the Sagnac effect, is a positive measurement of ether wind. Is that correct?
Well, the motion of the ether, whether it's in the linear or rotational form, affects the motion of the matter of light, the speed of light, according to the direction of the light relative to the motion of the ether. In other words, C plus V is a vector addition.
Yes, I see what you're saying. Okay.
Yeah. So, you really don't have to distinguish because of the Wang experiment. You don't have to distinguish rotational and linear. Whenever there's motion of ether, speed v relative to a coordinate system, a reference frame, there will be an effect on light given by v plus v. Whether the v is rotational or linear doesn't matter. That's what Wang shows.
Yeah, when he generalized it was making him equivalent for both. So he was saying, because they try and wrap it up as like the Sagnac effect is explicitly rotation, but when he generalized it, he was saying that it doesn't matter. And then you can apply the same thing to any configuration for any interferometer. So orthogonal setup like Michelson-Morley or a closed loop circuit, they all measure the same thing, the rotation of the stars.
I see. Yeah, I'm just curious because I think that we seem to be in agreement that let me see exactly what you said. So if the decay rate of muons were demonstrably the same as on the ground, then that could only be explained by time dilation. But what I guess I'm not understanding is what the affirmative evidence is for the ether wind having a differential velocity at altitude, other than that what's measured based on the Sagnac effect in satellites. I'm just curious how you can, because I understand that Dayton Miller, presumably, according to your paradigm, was able to measure ether wind, as they say, at lower and higher altitudes. At least that's what's claimed by the ether theorists. But I don't see a direct extension of that interferometric measurement at altitudes that would be relevant for the decay of muons. So is it simply the time effect in the satellites, or what is the affirmative evidence that such a wind even exists at altitude, much less has a difference in velocity relative to the surface?
There's a
Well, as I pointed out before, the altitude of the GPS satellites is reflected in the range equation, because that changes the relative speed of the ether, changes the calculation of the range of the satellite relative to the ground station. So you're asking how is there ether proof of the variation of ether with altitude? Well, GPS is one of one of the examples. The other one, which requires more development, is what I told you: the opposite flowing ether winds from the sun and the moon cancel out the ether rotation of the firmament, the stars, and that's why in our ether model we can correctly predict the altitude of the geostationary satellite. When the satellites are below the geostationary distance, what direction do they move? Eastward, right? When satellites are above the geostationary distance, what direction do they move? Westward. All right. So at that boundary, you have the exact cancellation of the eastward ether and the westward ether. And that's our proof, as demonstrated by the geostationary satellite, of how the ether winds predict the geostationary phenomenon.
And just to, I don't want to take up too much time. Thank you so much for those answers, Bennett. That was Dr. Bennett, that was extremely helpful in my understanding. The only other thing I would ask is there any uncertainty in where those satellites are located as a function of distance from the surface in your view? And then after that, I'm good and we can keep going. Sorry.
There's an uncertainty in every measurement, Morty.
Oh, okay. Yeah, I agree.
Dr. Bennett, thanks for the explanation about muons. I had not thought about that, but perhaps that same effect with which when the particles are accelerated at extremely high speeds in an accelerator and they're said to gain mass. Well, they gain energy, right? It's increase in energy that they're measuring and converting to mass. But perhaps that's the way in which the half-life is affected, because the half-life is actually just a rate of radiative decay. They're decaying via energy radiation. And so if you think of them as little vortices of ether, right? When they're at very high altitudes, the faster they're moving, the faster they're passing through ether. And since they're made of ether and they're kind of spinning, and that spin is decaying, and irradiating off little jettisons of decays, which is just ether also, then if it passes through more ether, that kind of helps it to maintain its spin and not decay as quickly, in my head at least. So it seems plausible that would be able to explain why they would decay slower when passing through more ether at a quicker rate.
Definitely requires more thought. Remember that the cosmic rays, when they arrive, are carrying ether with them. Being mass, they drag the ether along with them, just like Sagnac's round rotating turntable dragged the ether around same direction as the rotation and at the same speed, the same angular speed. The muon particles are dragging ether along with them. So the ether is moving at almost the speed of light, which means the light particles are traveling at almost twice the speed of light, because c plus v is almost 2c, where v is, within 1 or 2% of the speed of light. Yeah, so you got to think about this. It's an entirely new world. To think in terms of an existing of something which is present throughout the world, throughout the universe. It's ubiquitous, and it indirectly affects light and also matter to less extent. So the experiments that are focused on ether, like those of Atsukovsky, are very important in exploring what this new paradigm of ether motion, which so far has explained all of the things and that are claimed by mainstream, and explained in some cases why some of the mainstream beliefs are incorrect, like special relativity and general relativity, which attempt to use relativity principles, which are only kinematic, and apply them to dynamics. And so that's one of the fundamental problems that hasn't been resolved, probably can't be resolved between relativity and ether models. Okay, let's move on.
Cool. Okay.
Carol.
Are you able to see my screen?
Yep.
Excellent. So I will be building off of the affirmative statement that Peter has made, that the theory of general relativity as it stands and its encapsulation of special relativity fully is describable within this notion of ether. We will then build off of the specific experiments in the late 19th century and early 20th century that confirm that effect, and discuss the role of those experiments in furthering our understanding of the ether as it exists. What's beautiful about this topic is that we often get to see in physics this phenomenon of the macro scale translating to the micro scale. And what you're seeing here from a video from Veritaserum is an illustration of a wave interference pattern of constructive and destructive interference. That pattern is created by any sort of mass waves or light waves, which are propagating, and leads to the ability to perform interferometric studies on things like phase shift. The first sort of experiments that we had related to this notion of the ether came in the mid to late 19th century. Earlier than that, we had the theory of Fresnel, which described some of the properties of what he thought might be a situation of an ether. The theories of Newton, which established this idea of what an ether might be. But all of these sort of had the idea that ether would have to be absolute in some sense relative to the Earth. Airy's experiment was very interesting because it provided a direct measurement, as shown on the left with a normal telescope versus a water-filled telescope, and through an inability to measure an expected deflection, demonstrated for the first time that there might not be that absolute frame of ether that we were looking for. Now, this was the basis in later experiments for the beautiful device of Michelson and Morley. This is one of the greatest experiments ever conducted in the history of physics, where a block was suspended on an annular ring of mercury. The interferometric pattern would then be entrained through the ether if it formed a medium that was absolute and stationary relative to the Earth, and that ability to measure the resulting effect on the interferometry, those wave patterns that we talked about, would then form a test of whether that absolute frame existed. Now, what did we find in this experiment? As was confirmed many times in later experiments, particularly in 1926 with a different interferometer or a smaller scale, that absolute nature of the ether as we thought of it was not what we observed. So how did this influence Einstein? Well, you may have heard this classic quote. While I was thinking of this problem in my student years, I came to know the strange result of Michelson's experiment. Soon I came to the conclusion that our idea about the motion of the Earth with respect to the ether is incorrect. If we admit Michelson's null result as a fact, this was the first path that led me to the special theory of relativity, among other things. And I thank our Aether cosmology friends for bringing this beautiful quote of Einstein to our attention. Now, refinements to the theory wanted to test essentially what were the other kind of things we could detect about the ether. And Sagnac, in particular, had a sort of different interpretation of the ether relative to Einstein. But he had this idea of a rotating loop interferometer and wanted to test if by rotating it through an assumed stationary ether medium, you would observe a phase shift in the light. And indeed, that phase shift was observed. However, what has been confirmed countless times since then and shortly thereafter was that such an effect was entirely explainable within the framework of special relativity and actually provides strong evidence for the isotropic nature of light. At the summit of Mount Wilson, Dayton Miller provided further evidence for the nature of the ether, measuring very precisely the unexpected Aether drift, which would be sort of altitude and location dependent. Now, initially, this was very difficult to explain. However, as we'll show later on in open discussion, and we can provide papers to this effect, we now know in a relativistic sense how we can describe the ether on the basis of this experiment. And then we come to sort of the last great classical interferometer, I call it, which is the work of Michelson, Gale, and Pearson. And this was, again, a measurement of the assumption of a stationary ether relative to the Earth's rotation. Again, anytime we would entrain the light through a stationary ether, the expectation under the theory of Fresnel was that there would be a resultant drag affecting a phase shift. This basically allowed us to confirm that no such stationary ether exists, and also provided extremely strong evidence for the theory of relativity as it exists. Now, Einstein wasn't divorced from all of these
experiments. And in a letter to Lorentz, he famously stated this equation. And this relates directly to our characterization of ether in the prior construction, that the structure of the... Okay, yeah, we'll stop there.
Okay. Whoever's going first, Alan or Shane, you have 5 minutes.
Got it. Yep, but we don't think we need to screen share or anything, so we'll be fine. We just have to speak, I think.
Okay.
So
before we moved on, I wanted to point out another contradiction from Peter's argument. But he was arguing that link contraction and time dilation are apparent effects and they don't happen in the moving frame. And then he later tried to use link contraction and time dilation for the muon. Which is like,
that. He did.
Like
he totally did that.
They're explicitly defined by Einstein, you know, because somebody was, you know, made a similar argument, and they were like, it's an apparent effect, it's not real, it can't be tested. And Einstein specifically was like, nah, they're definitely real effects in the moving frame. Trust us, bro. If you had some observer non-co-moving with everybody, his rod would be measured differently from the moving frame rod. So it's not an apparent effect, right? And then you're going to turn around and invoke it as a mechanism to try and explain an experiment, like, you know, straight slipping dog. Anyway, continue. Or unless you wanted to add anything onto that.
No, that's good.
I have some comments. The citation of Airy's failure as supporting the relativity point of view, that's been refuted by, well, my presentations. I think I covered it once or twice in the videos. And also Malcolm Bowden's video is an excellent presentation of the two interpretations, the consequences of Airy's failure. Number one, that the Earth is stationary. Number two, that there is an ether wind that is moving the light beam sideways as the starlight comes from its source to Earth. And that is a yearly annual motion, which is support for both ether and geostatism or geocentrism. So Airy's failure actually can be correctly interpreted as supporting stationary Earth and the presence of a fluid ether. Now, Sagnac, if you read the English translation of his experiments, number one, he did this experiment in 1913, 8 years after the famous special relativity paper of Einstein, in order to disprove Einstein's relativity. And he said that he interpreted his results, as we do, as the dragging of ether in a vortex or in a whirlpool, I think he called it, whatever the word is in French. And so even in the experiment description, which I urge you to read, Sagnac interpreted his own experiment as showing, number one, that the speed of light is anisotropic. It is not a constant c, and it can be explained by the dragging of ether around a rotating mass. Other comments? I think again it was stated that ether was assumed to be static, rigid. Of course, our model includes ether dynamics, ether winds, and vortices. So that would be another example of a red herring. Okay, let's go.
I'll do a little bit of a contextualization for the open, a little bit of the meta. Essentially, right, even though our components have combined space-time and relativity into their wonderful position as ether cosmologists, we welcome them. But only those who don't understand relativity actually believe in it in any capacity. Only by surrendering your understanding to other men can you actually stand upon the pit of sand and pretend it to be a solid foundation. And in the words of Nikola Tesla, right, and when he described relativity, he said, Einstein's relativity work is a magnificent mathematical garb which fascinates, dazzles, and makes people blind to the underlying errors. The theory is like a beggar clothed in purple whom ignorant people take for a king. Its exponents are brilliant men, but they are metaphysicists rather than scientists, right? So it's relativity theory has been around for over a century, and to this day, the acolytes in support of the theory have actually surrendered their faculties to equations and concepts that even they don't fully understand or even care to understand in most cases. The people depend on the understanding of others with a severe appeal to majority and to authority so completely that it's almost a form of surrender. Those who don't understand it actually cannot see how absurd it is. The classical proofs of relativity are often cited to hand-wave dismiss any criticisms, but each one of those gets actually destroyed when you look into the details. We'll address many of those tonight. Another quote from our boy Thomas Dennis says, "It's impossible to teach special relativity without deceiving the student." That's from Science and Philosophy 10, number 2, 2022, pages 146 to 67. And when you get down to the so-called proofs, right, including the perihelion precession of Mercury, the gravitational redshift, the alleged detection of gravitational waves at LIGO through embedded and nested neural network and noise data, which gets elevated through a series of filters, which actually get designed to produce the data they're looking for, are actually nothing more than mathematical tricks and misrepresentations of data. Right? In all cases, the predictions are actually postdictions, disguised as predictions, straight up copied, or completely fraudulent. When you get the concept of space-time as a physical entity, it's purely imaginary. It cannot possibly have physical qualities. To apply physical qualities to a concept is reification, severely lacks any experimental proof or any sort of backing in science or empiricism. And the use of metric tensors and four-dimensional coordinates doesn't actually change that. It just makes it a mathematical trick, even though the speed of light is constant, right? Which is a primary postulate of special relativity. It's shown basic experiments in ECEI and ECF that this is not the case. And just to wrap it up here, we'll contend that relativity has inverted our understanding of the universe, leading to absurd claims about cosmic distances, timescales, and unprovable measurements and frames of reality that will never exist, that no one can ever verify. I advocate that we return to experiment-driven empiricism, and we can only deal with what we can see and deal with and measure. And the lab frame is where all experiments take place, where all measurements exist, the only place where you can take measurements. And I cede my time to Alan.
Do we want to pause here? That was a lot. Anyone have any? Shane, do you have anything you want to say? I would say real quickly that that was a great opener, man. I don't know if I really grasped how great of an opener he had when I watched it originally. That was crammed a lot of very good stuff in there. It was well said, man. Really laying out the kind of philosophical. It really comes. It gets really confusing because you start getting into these scientific arguments, but they end up being quite unfruitful when you don't get like that what you just laid out right there is a philosophical bedrock that if both parties can't agree on this relativistic, these relativistic coordinates, then it's just, we're at a philosophical impasse. So I like the way you laid that out. Anyone else?
I think the strategy should be to make the arguments as simple as possible. I think I said that at the beginning, and I don't know, just simplify as much as possible, so that, for example, someone in the audience can repeat what you said, showing that they understood it. Other than that, I don't have any other comments.
It's hard with relativity because I feel like, there's no way to simplify what we're disagreeing with. It's like, it's a conundrum because it's like, yeah, I don't disagree that in a theoretical reference frame, that could be a thing, but that's just an unfruitful thought exercise. And so you have to anything past that, you're kind of engaging in this thought exercise. And I don't know, it's like it feels unfruitful from the start because you're already past the philosophical bedrock.
Yeah, it's not a question of relativity good, ether bad. Some kind of a general statement like that. Galilean relativity is acceptable. In fact, that's what the model should be using. Galilean relativity in order to make measurements. As far as the ether is concerned, we've already pointed out that we don't believe in a static ether like Lorentz. We believe in an ether that has static components and also dynamic components, like the ether wind and the ether whirlpools. So you must distinguish the basis for what you're agreeing on. We agree with Galilean relativity. We agree with ether when it's defined as both possibly static and dynamic. And that difference should have been outlined in the discussion, in the cross-exam. These are the differences that we have between the two sides.
Well
Yeah.
said.
Yeah, that's great input. All right, let's move on here.
All righty, Alan, whenever you want to start, it's all yours.
Thank you. You see that?
We do.
All right, cool. In the ether framework, space and time are absolute. All measurements of velocity with respect to the speed of light are measured as c plus or minus v and can be answered in the first order as a ratio of v over c or at a higher order without invoking the gamma factor for space-time symmetry. Relativity theory makes use of covariance to satisfy linear orthogonal transformations to support the principle of the constancy of c. In this manner, a geometrically convenient position is invoked to facilitate a stationary frame relative to some observer moving at a constant velocity. By using covariance, the x-axis and time axis will be changed as a function of the moving observer's velocity squared over c squared. This is called link contraction and time dilation. These effects have no explanatory power over absolute measurements of velocity made by interferometric experiment. In order for link contraction and time dilation to be true, you must first assume an unmeasured velocity to be the cause of the produced second-order effects, which render the observer's ability to measure his velocity using light impossible in his own frame. Absolute time and space can be demonstrated with GPS and interferometry. Here we have Carroll Alley in 1979 proclaiming that relativity exists in GPS, and then 17 years later in a GPS overview, he's begging for it to be implemented, specifically the relativity of simultaneity and the associated Lorentz transformations. In 2000, we have Neil Ashby confirming that GPS uses a Galilean synced time frame for the ECI and ECEF frame, which is linked to the stars. Events will always occur simultaneously in the ether, regardless of the state of motion for the observers. But most importantly, this framework is based on an absolute fixed lab frame, and the ether will serve as the mechanism that facilitates Galilean velocity transformations in C. For predictions of the physical properties of the ether, they are as follows. There will be an anisotropic effect, a height effect, a space effect, and a hydroaerodynamic effect. The anisotropic effect is that there will be a preferred direction in the speed of light going east and west, and there won't be one going north and south. The height effect will be that there will be a vertical velocity gradient that increases that will increase the preferred direction bias as you increase in altitude. This is substantiated by Miller, Galev, and the Kennedy and Thorndike experiment. The space effect is that there will be a measured periodicity throughout the day and throughout the year that corresponds to the position of the stars and the sun. The hydroaerodynamic effect is that the velocity of electromagnetic waves will be affected by the parameters directed by the directed system, i.e. the tubes and chambers of the interferometer. Conductors or dielectric insulators used as shielding will affect the turbulent and laminar flow of the ether wind in the same respect that it would for any other gas or liquid that experiences flow through a tube. Relativity is based primarily on the principle of relativity of simultaneity. It states that two observers are given an arbitrarily agreed upon defined time for an arbitrary coordinate system, and then in that coordinate system, events that occur simultaneous in one frame will not occur simultaneously for the other frame. Based upon that principle of relativity of simultaneity, two postulates are put forward. Postulate one is that all inertial reference frames are equally valid. An inertial reference frame defined in relativity theory is a frame that's in uniform rectilinear motion at a constant velocity. In relativity theory, there is no preferred frame. Postulate two is the constancy of C is irrespective of the motion of the source of the observer in an inertial frame as defined by the first postulate. The consequences of these postulates leads to observers making measurements that are different for length and time based on the constancy of C relative to the square of their velocity over C squared. The physical mechanism of link contraction and time dilation is ambiguous with no clear explanation, i.e. lattice structure compression. But the fact remains that in order for C to remain a constant in a moving frame, the moving observer must be physically contracted in his frame. Otherwise, C would measure relative to the observer's velocity and not the other way around. To falsify relativity theory will show that its postulates and principles do not hold true in the reality that it claims to have explanatory power over. Starting with the philosophy of relativity, of simultaneity, and then in cases of electromagnetic propagation and processes making the wrong prediction for relative motion, it will show that the postulates are false. In the case of the unipolar dynamo paradox, the Sagnac effect in a uniformly rotating frame, and also the linear variant and GPS all require a preferred frame to make the correct prediction. All motion is relative. Relative to what is the question? We'll show that a stationary lab frame makes the correct prediction every time in regards to electromagnetic processes. And the Sagnac effect has never once in the history of relativity ever been derived as a relativistic effect, which we will definitely be going over. That's the end of my time.
Okay, Ross.
All right. So, I would say, go ahead, Cassandra.
Well, I just repeat what I noted at the beginning. The experiments that were presented by the relativists were basically the same as I would have presented, except I would have pointed out how an ether wind or a dynamic ether can explain the experiments. And that again goes back to a lack of definition of what ether is and disallowing an ether that can be dragged or influenced by the motion of mass. So Alan gave a good summary of basically all of our beliefs, but as one who's listening in the audience, you would want to hear, how does this relate to what was presented by the relativists? And all you really need to do is use some of the diagrams that I used on the slides. The Newton's bucket, the Wang, the Aries failure, the Michelson-Morley, all of those are relevant to establishing, number one, an absolute lab frame, and number two, a fluid ether. So that's what alpha stands for, those two concepts. That's part of the strategy. That's the part of the setup and the practice debate that would make that obvious that's the focus of the debate. Again, that's my opinion. And of course, the relativists would have different one. That's it.
Excellent. Thank you. Anyone else?
Yeah, I just want to say that was a surgical decapitation. You know.
You did move really fast. It was funny. I remember right before Riggs was like, "Yo, Alan, I want to put in a request that you don't go too fast." You're like, negative. This was fast.
Yeah,
Dude, I didn't know you can talk that fast. That was crazy.
I practiced it for like
clearly
since Monday. I practiced it a few times.
That was a lot. You got a lot in there for sure. But I know how it goes when you're trying to get those opening statements in for sure.
No,
you did well done. You know, like you were definitely more patient than you needed to be, and I applaud you for that, because I know it can be hard when you're in that situation.
Yeah. Agreed.
So that's pretty much it for the opening statements. Do we want to jump to another part?
26 minutes. We get to something I think is really important. 25:30. Let's go there.
All right.
Because it's slower for me, faster for you. How does that work?
Did you want to comment?
Oh no, just I think right around here into 26 minutes gets into the foundation of why special relativity was adopted, and I think that's an important kind of foundational point for the audience.
Okay, cool. Yeah, let's listen.
Light will be measured relative to your velocity.
Oh, it's
And if
relative.
I'm
Okay, we agree.
like
On
like
Earth,
every other
it's relative.
like every other wave.
So what is the reasoning behind the postulated constancy of C in inertial frames?
Well, that started by Voigt when he was trying to explain Dopplership with the postulate that the speed of light is constant for all inertial frames. He actually came up with the same derivation that that Lorentz used for his theory, and then that was used by Einstein. The equations are actually identical. I'll pull them up here in a second. So it comes from this lad.
That doesn't quite answer the question, though. What would be
one second. It answered it exactly, right? Because you said, "What's the basis for it?" Right? And it started right here with this guy Voigt on the principles of Doppler, where he was deriving the Doppler shift based on a constancy of C in all frames. This is the original link contraction and time dilation equation.
So what is the consequences of the constancy of the speed of light for the Einstein-Maxwell equations? And why is it important?
That you will experience link contraction and time dilation if you're in the moving frame. And that time and space are not absolute.
So when we speak specifically to the extension of the Maxwell equations within the Einstein-Maxwell theory, what is the effect of the speed of light on the laws of electromagnetism within those frames? That's a simple question. What is the effect of the speed of light within that frame?
I don't understand the question.
Shane, do you understand the question? Okay, can we stop there? Okay, so
I guess, Dr. Bennett, do you get what I was trying to get at with this question? Because I was trying to establish sort of like a foundational base as to why we talk about relativity versus ether and how it relates to electromagnetism. So I'd really love to get your feedback if I asked this well, if it was a malformed question, just from someone with your experience.
You should ask it again.
Yeah. So the question is, what is the consequences of the speed of light on the Einstein-Maxwell equations, particularly the Maxwell equations? And how did that relate to the development of relativity? Like, why is it important that the speed of light is constant?
Okay. It wasn't clear to me. I'm going to guess at what you're driving at. The effect of C in Maxwell's equation, where C is interpreted as the inverse square root of the product of the permeability and the permittivity, links the properties of electricity and magnetism to light, and that connection had not been made before. So I think you're driving at the fact that the identification of C in the equation as the speed of light links the electro and magnetic properties described in Maxwell's equations to the measured speed of light. And I think that's what you were driving at, but maybe not.
No, absolutely. You said that, I mean, as only someone with your experience can put things. That was extremely, I think, educational for everyone. I guess in the context of the debate, just looking for like feedback, critiques, like how to improve. Do you think that this was a good foundational question to ask, or should I have been focusing on something more akin to some of your clarifying questions that you had suggested? I guess just in general, as a general point of feedback for me.
As a general critique, I would say that you should make your questions simpler. Remember, you have an audience that you are trying to influence and try to convince that your side is correct. And also not, it sometimes seems like you think that the number of questions that you ask is a significant plus, whereas often it's just one or two questions that destroys the other side's argument. That's the most effective argument. So trying to establish your own position simply in its simplest form that you can. Remember, the audience is interested, but not probably well-versed scientifically. So simplicity, and I would ask fewer questions or propose fewer questions in order to simplify what the audience can draw from the discussion.
Okay, thank you. That's very helpful. I very much appreciate that.
You're welcome.
Cool. Should I continue playing, or any other thoughts or questions on that? Anybody?
Are you still? That's the clip that he wanted to show. So does anybody else have a
I think
suggestion
so.
for a
Yeah.
clip?
So, is there anything else we wanted to move on to here, or is there any other thoughts on this, or?
I don't know the timestamp for it, so maybe I would have to look. But maybe I can. Whose page is this? Is this off Jaren's page? Maybe I can look at it for this timestamp while you guys are talking.
Hold on, let me find. I can have the. Yeah, it's on Jaren's page. I think I have the link to it via I'll post it.
I can link it here. We can just.
Thanks, Morley.
Yeah, no problem.
Hey, what's Miller been up to?
Oh, he's just measuring the ether when playing that flute. You know him.
Oh shit! That sounds like old
It's
Miller.
not Shanklin speaking, is it?
No, dude, that's Morley.
Okay, yeah, Shanklin would sound at least twice as retarded as that. Okay.
Right. Agreed. Obviously.
Uh, 10440. Although I don't know if there's anything to be seen in the time between here. I mean, maybe we can skip back and skip around, but I would like to at least hear, since Mordwand is here, if he could recover this. Everyone remembers what topic this was, so he's going to make a statement here.
Oh yeah.
Solve this particular conundrum. There's a very well-known solution. This is a debate tactic to throw at you something that it's complex, that has to be drawn and calculated using angles and lengths.
Oh, can you back it up a little bit for the question?
It's presented in.
Yeah, the question you asked. Yeah, I was just. I guess we could focus on that before his response, but yeah.
It's well known.
I have 10330.
Can you stop that share for me, Peter? Thanks.
Suppose you have a moving train car at some velocity full of passengers, and there's a bomb at the center of the train car. The bomb is configured in such a way that it detonates if it receives simultaneous lightning strikes at the front and back, similar to the the standard example that they give for the moving train car and the stationary observer at the center. Right? With respect to the train, there's a stationary observer on a platform. At the exact moment the bomb-carrying train intersects with the stationary observer, lightning strikes the front and back of the train car. Okay? Does the bomb detonate, or is there a temporal divergence due to the velocity of the train?
Yes. I am familiar with that. It's a common, puzzle in relativity. And the solution is well known. I don't remember it.
That's a real shame. Sea Lion, you.
That is
So what would this
shame.
apply? So let's think about this.
Yeah, so I think what's going to happen next is I don't have a good response to this. So I think this was a bad moment for me, if I'm being honest. But I haven't been informed of the correct solution since then. In fact, there's a cool little thing that Bacon put together. 1 second, not to divert from this, but there's a neat little Lorentz transform app that Bacon wrote. Let me share that with you boys.
Oh, someone finally made the relativity calculator. I've been putting that off.
There you go.
I was gonna make one in Godot.
This is a pretty cool one. And he showed me the solution. So yeah, Did you have a question specifically related to this, Pietro? Or
Yeah. So I was going to ask you. I don't know if you've looked. You just said you haven't seen the solution yet, so I'm assuming you probably haven't looked at it since the debate. But
no, I have.
Okay. I didn't really hear it discussed. Sometimes it's difficult in the heat of like a moment or in a debate scene, to think on your feet in order to be able to make your question super granular for the other person. But like I never really heard you get questioned and down to the way to which I would wish to hear you answer, which is, do you understand what the implications are of, the bomb on the train scenario, of there being a difference between reference frames for the observance of simultaneous lightning strikes on the bomb, the implications on the bomb, and by extension, reality and the theory of relativity itself?
Yeah. So the short answer is no. I don't fully understand that at the moment. Despite having studied it. But my understanding is just the basics of the solution and the reason that how special relativity applies to make it not an issue. But to answer your specific question, I don't have a good answer at the moment.
Okay, so imagine, and you can, it's always about relative motion between the observers. Like, so it could be the train moving or the train station and the earth moving or whatever, it doesn't matter. It's just relative motion between the two. But, whether you have the antennas, the receiver antennas on the train or on the ground, it's the same situation. But either way, at the moment that, the observer on the ground, the stationary one, is lined up with, the midpoint of the train, which is lined up with the midpoint of the two receivers. Okay. And the midpoint's not even necessary either. But at that moment, even though we know the train is moving really, 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 really fast, at that moment, the observer that's on the ground, that's stationary, he sees in his frame lightning simultaneously strike both towers, and if and only if they're struck simultaneously do they flip the switch to the bomb.
Yeah.
If there is a difference between what he sees and what the people on the train see, that would mean that there is not an equivalence of those reference frames. And I don't see how you can reconcile. I don't see how you can like time has to be different according to relativity. Like it has to be different. And so if he sees it in his frame being simultaneous, the bomb would have to explode. But you can't have a bomb exploding in his reference frame and not exploding in the train frame. It's kind of the same thing with Newton's bucket. Like the bomb is the water being added to this situation.
I have a request.
Okay.
Mr. Bacon is present. I request a tag team in from Mr. Bacon, who has studied this problem more than I have.
But when they studied it, I guess they can bring them up. But do you understand, like in school, when they bring this problem up, it's usually a train in a tunnel. Same type of problem, though. The time on the train is different than the time on the ground. That's like saying the bucket frame and the star frame are different, but there's no consequence, right? There's nothing to test it against. There's no control to test it against. When you add the bomb to the train or you add the water to the bucket, that adds the control, and it allows you to differentiate between the two.
What do you mean by the control?
It adds something against which you can test to see whether like your prediction is correct or not, because otherwise they're equivalent without that third thing. Like relativity would say, oh, it could be the sky rotating and the world rotating around the bucket, or it could be the bucket rotating within the stationary world. If you have water in it, though, only one can be true, because you can look at the effects on the water just as we can look at the effects on the bomb. So I guess maybe the control is not the right word, but it provides a test case.
Can I respond to the thing about the train?
I mean, it's not my stream, bro. I don't mind.
Shoot for it, brother.
Oh, right. So yeah, when the lightning strikes both ends of the train, where the antennas are, the information that the lightning stroke to the two antennas have to meet at some point for the trigger to decide that it's going to blow up the train or not. So if you put the trigger, for example, in the middle, where it takes the same amount of time for the information to travel from both antennas to the center, and let's say that information travels at the speed of light, so it's just a wiring, then seen from the perspective of the observer that is stationary, that trigger that is in the middle of the two antennas is moving at a certain velocity lower than the speed of light, but the information from the two lightnings is constant under special relativity. So it's going to travel towards the center in the same velocity. However, the center is moving. So the lightning coming from the front of the train is going to hit the trigger first, and then the lightning coming from the back of the train is going to hit it lastly from the observer outside of the train that is stationary. So that observer seeing the information of the lightnings traveling through the wires getting to the trigger will see that one is going to get to the trigger first, and then the other one's going to get there. So even given the fact that it sees both lightning strikes the two ends at the same time, it's still going to see that the trigger won't be triggered because the information from one lightning is getting there first compared to the other one due to the movement of the train and the constancy of the speed of light.
All right.
Okay.
Ready for the refutation now? So that's an apparent effect, right? And you're correct, like the information would be delay. So there would be like a Doppler shift or some similar thing where it wouldn't be in line with the midpoint. But in tandem with that, you would still have to deny the simultaneous event, right? Because they both can't be linked to the same time. So like, yeah, if you account for the signal propagation to reach the train or whatever, yeah, the midpoints won't be aligned, but you must also deny the simultaneous event in the moving frame, which obviously occurs in reality. That's why GPS uses Galilean frames and not relativistic transformations. The events are simultaneous on Earth always, right?
Well, on the train, there's no relative motion between the receiver and the center and the antennas on the ends. That's why the observation is made at the point in which the midpoint of the train and the observer on the ground are perfectly aligned, because at that instantaneous moment, the observer on the ground that's stationary is also at the midpoint. So the midpoints are equivalent at that point. And so at that instantaneous moment, when the observer sees the instantaneous lightning strike, it should be occurring at the same time on the train. But then the train continues in motion. But as soon as the train does continue in motion, right, all the motion on the train frame is the same. It's all co-moving. So there's no relative motion. So the theory of relativity would not predict any differential for the light travel to the switch in the middle. So on the train frame, there's a contradiction with the theory because the observer frame would say they'd blow up, and the observer frame would say it was simultaneous at that instantaneous moment. But then once the train starts moving, having that signal on board at that when the instantaneous moment's unpaused, so to speak, into time, then it doesn't have a way to produce a differential since everything's co-moving. But the way that relativity states it, though, they say, oh, well, the train's moving, at all times it's moving, and because it's moving, there must be a transformation made.
Okay, I agree that it will only be simultaneous for one of the observers, but I don't see why that's a refutation. The relativity doesn't require that the things happen in the same order between all observers, just that the same things happen. And in this case, everything happens for both observers, not in the same order, not in the same amount of time, But everything that happens from one observer happens for the other. It just might not happen at the same time or in the same order. So I don't see the refutation.
The simultaneous
And
event. Go ahead.
Summarize the two solutions to this experiment, this train experiment. All right.
Fantastic.
I'm going to try the observer on the platform or the tracks, the stationary observer, which we would call the lab frame. Okay, what he observes is a light beam is going from the back of the train forward and another one going from the front towards the center in opposite directions. And the analysis of Einstein and others is that there is a difference in the concept of simultaneity, which is solved by assuming that time dilates. And it's equal. That is, if you're on the train and you're looking at the lab frame observer, the one on the tracks or the station, time dilates in that direction too. Now, what does the Aether model say? Based on Wang's experiment, which is appropriate because we have linear motion of the train and the light beam. Right, our analysis would say, according to alpha, that you must observe from the platform, from the lab frame. And what you see is not C constant in both directions, but you see C according to it's influenced by the motion of ether. So the light that leaves the back of the car moving towards the front is boosted by the speed of the train, V. So the light beam travels in the lab frame from the back of the train with a speed C plus V. The other point of view, an observer on the front of the car would also therefore stationary in the train frame, would see the speed of light would be C minus the speed of the train. So you have light beams moving at different speeds towards the center. And the arrival of those at the center would agree with what the Aether model predicts for both the on the train and the one on the in the lab frame. That is, the speed of light would actually be different for the two observers because of their different state of motion relative to the lab frame. So there is no time dilation. The difference in what they observe is due to the fact that the two observers are in different states of motion relative to the lab frame. Now, how do we know the lab frame is absolute? Because of Newton's bucket, which I went over briefly before, but there are notes on that in the presentations that I gave. All right, so the resolution of the simultaneity issue is resolved by considering the effect that ether has on the speed of light. That's it.
Just a physical mechanism every dang time, huh?
Well, remember what Wang showed. The glider speed is C plus V. The light speed is measured with the glider moving along in the forward direction. And when the light beam is off the back of the glider, it's C minus V. That's exactly what we have with this train experiment. It is
Yeah.
the constancy of the speed of light that is causing the problem.
Yeah. So, Dr. Bennett, to piggyback off of you, there's a very short paper. It's only 2 actual pages that these Chinese gentlemen wrote about this. What you're talking about, the invariant speed of light, and whether the simultaneity is apparent or actual. I'd love
It's
to.
actual.
Right. What the difference is between the actual event occurring and the observation of that actual event. It's the observation that's not simultaneous because light is a traveling wave, but the actual event itself is independent of the observation. And that was the point in the example. I don't know if you called it more. I said an instantaneous lightning strike. So I wasn't saying like a lightning strike at which the viewer sees the photons coming into his eyes, like with a delay. Like it was meant to be an instantaneous event, which you guys, anytime you have instantaneous events, you call it like quantum tunneling or evanescent waves or anything. But I don't want to get into that. That was the point. So would you mind if I brought this paper up, Alan?
No, go ahead. Be able to
All right,
screen share? You should be able to.
I'm not. I think it's because you're sharing.
This for a second.
Hang on, more Lee's coming down real quick. All right, you should be clear.
1 second. Yep. Can everybody see that?
Yes, sir.
So this paper by Chu Xiaoji and Chu Changkun, it says this paper re-examines the well-known topic of relativity of simultaneity. The latter is shown to be a false proposition due to an error in logic and confusion in fundamental concepts and epistemology by Einstein. Epistemology is just like, how do we know what we know, or how do we know, things about reality? Like, what's the basis of our knowledge? Those are the things that epistemology deals with. So it says
the rules of truth. Yeah.
Yes. Absolutism of course, is like my epistemology. It is what it is, right? And then our understanding is separate to that. But it says that this paper scrutinizes a basic proposition of SRT, special relativity theory, the epochal topic of the relativity of simultaneity, ROS. So the ROS is the conceptual foundation of the SRT, from which relativistic spacetime ideas were poured by Einstein into the Lorentz transformation, the LT, leading, as it has been said, to a great revolution in man's spacetime ideas, despite the fact that the expression for the Lorentz transformation retains the same form before and after Einstein. It's been hailed as one of the greatest theoretical discoveries in science of this century and is cited by almost every work on the special theory of relativity. Here, it's of great significance to analyze it in depth. This paper will show that the relativity of simultaneity is a false proposition because Einstein committed errors in logic and used confused concepts and epistemology. So then it goes. It uses actually this train car a thought experiment to make their point. So to expound to his views about relativity of simultaneity, Einstein supposed that a train traveling along a railway surrounding in vacua with a constant speed v in the direction shown in figure 1a, right here. So, and asked Einstein 1936, are two events, like two strokes of lightning, A and B, at opposite ends of the train, which are simultaneous with reference to the railway embankment, or the observer at the station, also simultaneous relative to the train? And then he answered the question, we shall show directly that the answer must be in negative. Why must the answer be in the negative? The reason in his direct proof is this. Just when the flashes of lightning occur at points A and B on the rails, the midpoint M prime of A to B on the moving train coincides precisely with the midpoint M of A to B on the rails. An observer M prime sitting at point M prime is hastening towards the beam of light coming from B, whilst he is riding on ahead of the beam of light coming from A. Hence, the observer will see the beam of light emitted from B earlier than he will see that emitted from A. So what's the meaning of this? Einstein concluded, observers who take the railway train as their reference body must therefore come to the conclusion that the lightning flash B took place earlier than the lightning flash A. Now, there are two questions which need to be made clear. Is Einstein's argument compatible with both of the two postulates of the special theory of relativity? The principle of the invariance of the velocity of light pivotal and the principle of relativity? And number two, could the observers at the train come to the conclusion that the lightning flash B took place earlier only because observer M prime sees the beam of light emitted from B earlier than the light from A? We can show that both answers must be in the negative. So there was a logical error in Einstein's argument. It is evident that the figure or the diagram in figure 1b is entirely equivalent to that in figure 1a because, according to the principle of relativity, the motion of the train toward the right relative to the rails is equivalent to the motion of the rails toward the left relative to the train. And for figure 1b, where the train is immobile, or even if it is mobile as shown in figure 1a, the argument below remains valid. If the principle of the invariance of the velocity of light were valid, both the velocities of light from A and B with respect to the train should also be the same and equal to C, so that the observer at midpoint M prime should also see the two beams simultaneously. And then here's what it's showing, A and B. So it's the train moving relative to the embankment or the embankment moving relative to the train. But then if this is true, if they see, C being C, then where is the relativity of simultaneity? How different our argument is from Einstein's. Thus, which is correct, Einstein's or ours? It is clear from the above that our argument has done nothing but follow the two postulates of special relativity theory, and its validity is therefore unquestionable. But Einstein's direct proof has disregarded the principle of the invariance of the velocity of light set forth by himself. His comment is that the observer M prime hastening towards will see the beam of light emitted from B earlier. This is nothing but an introduction on the sly of an influence of the speed v on the velocity of light. He's adding plus or minus v to C. We must therefore conclude that Einstein's argument has violated at least one of the two postulates, namely the principle of the invariance of the velocity of light. We come to the unavoidable dilemma that either the two beams of light will arrive simultaneously at point M prime, as at point M, or invariant light speed must be invalid, and so the relativity of simultaneity must be false. Here, Einstein committed a logical error, which is real and not only apparent as claimed by Einstein. In his 1905 paper, Einstein wrote, taking into consideration the principle of the constancy of the velocity of light, we find that the time difference between B and A equals the distance between them over C minus V, and T prime of the distance between the two of T prime B and TA equals the distance between them over C plus V. What is that, a little C minus V and C plus V with Einstein? What's that? This statement is self-contradictory. Explicitly, C minus V and C plus V are the difference in the sum of speed V and the velocity of light C, respectively, and they are irreconcilable with the principle of the invariance of the velocity of light. They're irreconcilable with light speed invariance. You can't have that. You can't have a sub-light speed velocity in any way adding or subtracting from the velocity of light. There are thus serious grounds for doubt that Einstein was taking into consideration light speed invariance. In fact, as we have pointed out before, there is no truth to the claim that light speed invariance has been confirmed experimentally. On the contrary, there are disproofs of light speed invariance. Moreover, Einstein never put his light speed invariance into practice. For example, in deducing the Lorentz transformation in his 1905 paper, Einstein took various values for the light velocity, such as c minus v, c plus v, and the square root of c squared minus v squared, etc. The fact that for one and the same pair of events, observer M prime has an observational result different from what observer M has shows directly that A, a statement about the velocity of propagation of light has no direct physical meaning without a definition of the source of light. B, the observational effects corresponding to the two inertial systems differ from each other, and this automatically refutes Einstein's myth that the equivalence between inertial systems is infallible. In fact, the observed radial Doppler shift, which roughly corresponds to what happens in Figure 1, is one of the best disproofs of the infallible equivalence of inertial frames, since one and the same light source gives different observational results for different observers having different speeds relative to the source. C. Indeed, the alleged principle of relativity has been misinterpreted by Einstein and needs to be clarified and corrected, which will be dealt with separately and later. We now proceed to the second question, which is not quite as simple a question as it seemed to Einstein, since it involves a profound epistemological problem. Did you want to say something? Epistemology tells us that... Oh, go ahead.
Well, I would like to point out the relevance of the Wang experiment when you're finished, Piso.
Absolutely, I would love that. Epistemology tells us that what an event or an object is observed to be is one thing, and what it is in reality is another, though there is a relation between the two. For instance, the sun looks like a small disk, but in reality it is quite large. Similarly, whether the two flashes of lightning are observed simultaneously is one thing, and whether they take place simultaneously is another. Even according to the special relativity theory, if the two strokes of lightning strike at the train instead of the rails, the result should be opposite. It is observer M prime, not M, who will see the two beams simultaneously, while observer M must note the beam coming from A, no longer B, in this case, earlier than that coming from B. Thus it follows that A, the simultaneity of two lightning flashes with respect to the system in which the two strokes of lightning strike is uniquely determined. Hence, we may not deny the fact that real simultaneity exists in this sense in the special relativity theory. This might be termed proper simultaneity. And B, the alleged relativity of simultaneity is an apparent effect, which we may call image simultaneity, because it results from light having to travel with a finite time to produce the image that we see with our eyes. C, the law of propagation of light, which Einstein always identifies with light speed invariance, has nothing to do with light speed invariance. And D, there is no physical or real reason for the observers at the train to come to the conclusion that the lightning flash B took place earlier, even though observer M prime sees the lightning flash at B earlier than the flash at A. So to sum up, this discussion has shown that 1. The relativity of simultaneity is a false proposition in which Einstein had made serious mistakes of two kinds. He overlooked a logical flaw in his inference, and he confused the concept of something taking place with that of seeing it take place, and he took apparent effects of events to be equivalent with the events themselves. 2. The principle of relativity and the law of light propagation have nothing to do with light speed invariance. They have been distorted by Einstein and the others and need to be corrected. 3. The equivalence between different inertial frames is not infallible. The Doppler effect is the best disproof of the equivalence of inertial frames, since one and the same light source gives different observational results for different inertial frames. 4, the relativity of simultaneity is only an apparent observational effect, and it cannot preclude the existence of real simultaneity. And 5, since relativity of simultaneity is invalid, it therefore provides no premise for Einstein to conclude that every reference body or every coordinate system has its own particular time. Thus, the special relativity theory and the relativistic spacetime theory are built on a false foundation. Many thanks. All right. Short and sweet, but the logic is straight to the point.
Yes. Not founded on experiments, but on a logical analysis of Einstein's argument. The Wang experiment is an experimental disproof, which is required by the scientific method. And let me indicate how. First of all, postulate number 2 in special relativity is the speed of light is constant. The Wang experiment shows that when the glider is moving along with the light beam, that it's the speed of light plus the speed of the glider relative to the lab frame, c plus v. When the glider moves in the opposite direction, it's c minus v. In both cases, c is not constant. So the second postulate of second relativity is disproven by what I just pointed out. The first postulate said.
Oh, I'm sorry. What do you mean by glider?
Well, in the Wang experiment, there is an air bearing glider that is used on a track to eliminate friction, and it is the object in which a light beam can be reflected off of, or can be a light source for.
Are we talking about a different? Are you saying slider with an S as in Sierra, or glider as in golf?
Glider as in golf. Yeah.
Okay. When I think glider, I'm thinking of like I think of like a hang glider. When you think glider, I'm thinking of like a plane. I'm sorry. He's talking about the conveyor belt. Okay.
Yeah, the conveyor was configured using air.
I'm talking about an air friction glider, which is what we called it.
Okay.
It's supported on jets of air that keep it from being affected by friction.
Oh.
Okay.
Yeah.
Okay, so you have the diagram right there on the screen. The second postulate is constant speed of light. All right, that's refuted. The first postulate also is refuted. What does it say? It says that in an inertial frame, the laws of physics are valid. What is an inertial frame? It's one in which the laws of physics are valid. So are the laws of physics valid in any frame, or is there an absolute frame in which the laws of physics only are valid? The answer is given by Newton's bucket. If you do experiments in the Earth's frame, the lab frame, as Newton did, he correctly predicted a centrifugal force on the water. So the laws of physics are valid in Newton's frame, which was the lab frame. He considered, though, if he were on the bucket and observing the water, which was stationary with respect to him because it was co-rotating in the lab frame, he would predict, using his laws, that there is no rotational motion, so there is no centrifugal force. But as has been known for over 300 years, what would be observed is the actual vortex formed by a centrifugal force exerted on the water. So that experiment, Newton's bucket, indicates that there's an absolute lab frame in which the laws of physics are valid. So in other words, the Earth is an inertial frame. Any other frame moving with respect to the lab is not an inertial frame, inertial, and therefore the laws of physics are not obeyed. So both postulates of Einstein are disproved by the Wang experiment. The Sagnac experiment only disproves C plus B equals C. But because it isn't linear motion, it doesn't include all possible motion, only rotational motion.
Right.
So that is my cleanest response to the to special relativity. You know, Sagnac, in fact, did his experiment in 1913 deliberately to disprove special relativity. And he claimed, if you read the experiment, translated from French, you'll see that he said, I claim that the speed that I measured for the speed of light, which was c plus v, is due to the formation of an ether whirlpool around the rotating platform. And that's his explanation. And that's the explanation that's been used ever since then.
So I didn't. Well, yeah, because I guess the ether is getting pulled down just like the water would be into the bucket, and it's resting on the table. And so when he spins the table, it spins it just like the bucket would spin the water. That makes sense. I pulled up this quote.
Or when
oh, go ahead.
The glider drags the ether along with it when it's sliding back and forth on that track.
Yeah, the ether that's
Okay, so
resting on top of it.
Yeah, so that's the linear version of the Sagnac effect. The ether is being dragged in a straight line, not rotating around the center.
Right. This blue and red right here. So there's this blue and red right here. Like this makes one quote that at the beginning of the paper, and I was telling you more one. I'm glad he brought up Wang because we said we were going to talk about it. But he makes this note. Our experiments are different from the Fizotop experiment, the drag experiment of a moving medium, because in the Fizotop experiment, there is relative motion between the light path and the medium, water or glass. The result of the Fizotop experiment is dependent on the refractive index of the medium, and the drag coefficient is 0 when the refractive index is 1. In our experiment, as in the fiber optic gyroscope, there is no relative motion between the light path and the medium, which is glass fiber or air core fiber. So the light path is in the medium, which is, co-rotating. So like the light is traveling through the thing that's moving. So there can't be any relative motion between it. So when you look at the theory of relativity to try to explain Wang's results, you wouldn't be able to. It doesn't make sense because there is no relative motion to be found. The only way you can invoke relative motion is if you say relative motion with respect to some fixed absolute frame in space.
Yeah, well said.
The lab frame.
The lab frame, right.
Can we go back to the paper you just read, just for a second? I just wanted to deal with the semantic in one of their reactions, and it had to do with the train itself. Figuring out M prime and receiving it at the ahead of train signal first, etc., and that they would therefore assume that flash B took place earlier. I think what's left out of this analysis here in their conclusion building is that the train's got a speedometer relative to the track that it's on. And that if anybody would know the distance between the train and the received distances, they could do their own math and figure out for themselves, due to their own velocity, that they were in fact simultaneous events. Do you follow that?
You're saying that they could back derive the time delay and add it to the time to get the absolute time?
Based on the distance they were from those 2 points when they received those two signals. Yeah, that's a straight up calculation, right? I think they missed that in their analysis here, and they just assume the train would come to that conclusion. But I mean, I agree. It's just a semantic. It's just something that struck me as a little bit sideways. Anyways, carry on.
Yeah, so Mordwand, I don't know if I mean, so he's referencing what the results are, and he's spot on with what the results are and the implications of Wang. But I don't know if you actually know what happened in this experiment, other than the fact that there's a conveyor belt involved. Do you know what actually, like, what he did, Mordwand?
The Wang interferometer?
Yeah, this right here on the screen.
Yeah, I mean, so my understanding is that the claim was that he was able to measure linear absolute velocity in the interferometer. I think that's the central claim, right? I don't understand the minutia of the apparatus, however, so if you'd like to explain that to me, I'd appreciate it.
Sure. Okay, so you can see this big loop here. Now, he has this loop stretched out to exaggerate a point. The point is even though this is a loop, it's a closed loop, it's a rotating loop, right? On this part right here, around these spindles on the left and right, these left and right spindles, right here, it actually rotates, right? Like the loop actually goes in a circular motion once it gets here. But in all the sections in the middle, the loop is just moving linearly, correct?
Insofar as I can tell.
Right, because I mean, we can look at it and see that it's a straight line.
And do we have a photo of the actual apparatus? I mean, this is a reproduction, but
I would ask the Naval Research Laboratory that took him on twice to do this multiple times, and funded him and gave him the equipment, but I don't have any photos.
Yeah, I see it in the patent, because in the patent too, it's all diagrams. I'm just curious what the actual interferometer looked like from that perspective. Like,
yeah, I can explain the patent after this.
All right, go for it.
But anyways, so what he does is he has like this conveyor belt, right? Which is taking this FOG, fiber optic gyroscope, which is measuring everything, right? And he's got this cable attached to it, and the cable is attached to here, so that when this moves, when this conveyor belt's moving at some linear speed of v, this loop is also turning at that same linear speed v. Now, in this section around this spindle, of course, you would represent it not as a linear speed v, but as a rotational speed, right? You would consider it to be a radial velocity instead of a linear one. But it doesn't matter because it's all still the same, right? This speed right here is equivalent to this speed here. This is just the line wrapped around.
Pizzo, we cannot see your mouse, but we can see things you select.
Okay, thank you. So this part right here, this spindle, it's moving at the same speed as this. Just because you take the line and you wrap it around a spindle doesn't mean that it's not still moving at the same rate. We know it's all moving at the same rate because this is all attached. You see this orange cable right here. That's got everything hooked up and synced up. So we know it's all synced up. And in this paper, what he does is he shows the classic Sagnac equation for a rotating table, which would be like the rotational equation based on a radial velocity, which is right here.
Yep.
And he shows a prediction that would make. And then he shows the linear velocity form of it, which would apply here and would apply here. And what's happened? Oh, go ahead.
The middle of the belt would be a separate effect than the parts that are spooled. Is that what you're saying?
Not a separate effect. He shows a separate equation because linear velocity is represented mathematically with a different variable and in different terms than radial velocity. But anyways, what they both
Can you show me that piece specifically?
Yeah,
still need to fully.
Yeah, the delta L is the effective length, which is defined by the linear moving segment. So if it was with respect to like the whole apparatus or whatever, you would use like the total length of the fiber, but he only uses the delta L of the linear moving portion. And actually a better version of this, if you scroll down to the parallelogram diagram, that's like the ultimate, that's the better one. That's the conclusion right there, right? So we got the stationary bottom piece. We got the two pieces going up to the side, to the top. Those cancel each other out. So all you have is the delta L, or the effective length of the top moving linear bit. And then that's represented by that equation of of just that moving segment. So it's like with respect to what is that measurement being made? If it was with the full apparatus, it would be, you would have to include the whole length of the fiber at the minimum.
Yeah, and so there's an omega equation, right? The omega variant is the rotational, and then the delta L variant is the linear. And so what he does here, and that's Alan's right, the parallelogram showing the same thing. It's just he does this first and then compares the two to show that they're equivalent. When this FOG here is moving to the left at a linear velocity, it is co-moving perfectly with this bottom half of the loop, right? And so that means that based on the theory of relativity, since the bottom half of the loop and the FOG are co-moving, then they're part of the same inertial frame. There's no relative motion between the two, so there should be no deviation in their measurements. So so in doing this, he isolates the top half of the loop up here because that is the only part of the loop that has a differential with the FOG because they're moving in opposite directions. Okay. So in doing so, he basically isolates like the one-way travel of the light. And what he does with the math is he shows that if he uses both equations to predict the fringes that will be produced, if he uses the omega equation for the radial turn rate, and he uses the linear equation for the linear turn velocity, both equations yield the same exact number of fringes produced, which correspond to what was actually measured. And he shows it plotted here. And then he does the same thing here. And shows it plotted here. And what he's able to do is he's actually able to show that if he takes with his patent, right? If he takes the fringe difference of the loop in one direction, which would be this one, versus the loop in the other direction, which would be this one, and he takes the fringe shift of the two different loops and subtracts them from one another, he'll get one resultant number which corresponds to the velocity of the object. So, in other words, if he was to put this whole setup into a little box and he was to mount that box to a car, right? He could take the fringe pattern of when that car is sitting still, and then he could put that car into motion because the box is in the car, so the box and car are co-moving. So the box is sitting still, and then the box is moving. And he can take the fringe pattern that's registered when the box is moving compared to when it was still, because it's all internal, subtract the difference between the moving fringe and the stationary fringe and get the resultant fringe. And that resultant fringe, when plugged into the equation, will perfectly predict the V, which is the velocity. And it doesn't, the box does not have to reference anything outside of itself. It doesn't reference the car. It doesn't reference the Earth. It doesn't reference the distant stars. It's all internal to the box. It's not referencing any reference frame other than its own, which means that within its own reference frame, it's able to derive what's called an absolute velocity, which is being taken with respect to absolute space.
So why hasn't Wang received a Nobel Prize for this work?
That's
because mainstream opposes it.
And besides, that's a non sequitur. That's a non sequitur to the point.
Yeah, it's the lowest form of argumentation. Though, right? It's the lowest form of argumentation possible. It's super annoying when people do that. And Bennett, do you want to tell the story of what happened when you tried to ask Wang about this and why he doesn't go anywhere with it?
Yeah, that sounds really interesting.
Yes, I called him up and I said, by the way, his phone number was available because he works at St. Cloud University, so you can find his phone number under the faculty listing. Otherwise, I wouldn't have been able to contact him. Anyway, this is St. Cloud University in Minnesota.
Excellent, thank you. Dr. G. Wang?
Ru Yong Wang.
Ru Wang. Oh, Ru Yang. Sorry, my bad. There's a few Wangs there.
Yo, just let the man speak, dog.
This is years ago. But I said, you've proven or disproven special relativity very effectively with your experiment. And he said, Then I said, why aren't you promoting it more vigorously? I mean, you did publish it in, I think, Vixra. I know we did it in Vixra. He did it one place else. And he was reluctant to promote it. And I'm not sure why, but it seems like he was afraid that he would lose his position, or he would lose the money that he was funded with from National Science Foundation, I think. So it was sort of the leverage that the funders had over his experiment, plus the fact that perhaps he thought his job would be at risk if he openly challenged special relativity. So that's one of the rare occasions where I actually spoke to one of the dissidents who oppose special relativity.
I'll tell you my experience with him real quick. So when I first came across this, I emailed him to confirm that his email address was like still active. So I didn't send like, what I wanted to ask him. I was just like, hey, I'm reaching out to see if this is still a valid contact email for you. I got some questions about your experiments regarding GPS and interferometry. He emailed me back pretty quickly and was like, yep, this is valid. I'm happy to help. Send your questions. So I just asked him two simple questions, and the first one was about this, what's the climate like in terms of, his experiments and thoughts on relativity are directly in opposition to the mainstream narrative. Like, do you experience any pushback in the academic field? And then the second was about the significance of the ECI and ECF frame, and he never emailed me back.
Gotcha.
So it's like he doesn't want to talk about relativity publicly or whatever, even though he publishes papers against it, but he will not speak out against it with his own, like outside of like a paper. You know what I mean?
Yeah, it's just interesting because he has and the other one, right? The success is the other one that's really well known is the successful GPS operations contradict.
Yep.
Is this the same one, or this is an earlier one? I'm sorry. Excuse my ignorance. This is one about ECI frame, right?
He doesn't mention the ECI ECF stuff specifically in that one, but the way he was getting at in that like led me to ask questions about it. So it was like directly influenced by that paper. But
just so you know, by the way, Mordwand, I mean, the whole like, why hasn't he been awarded for it and revolutionized the entire world of science? Like, I mean, me and you had a conversation one day about, the paradigms and the way that, people's philosophy holds their interpretations captive more than the science itself. But this isn't the first time he demonstrated it. This was just like a souped up version of the experiment. He did another one before this. In fact, there might have been two before this. But the first one that I know, that I can remember, he did with the Naval Research Laboratory, which he also did with this one. The first one was a great success, and that's where he first demonstrated this, and on a smaller scale. And they invited him back and gave him another grant to come into their lab and do it again, which was this time right here. Like, the Navy's not like handing out that money and just being like, "Oh yeah, that's cool, man. Come waste our time and money again next time. It was fun." Like, it doesn't work.
Yeah, I know it's interesting though, right? With the context of the Navy, right? Do you happen to know? This is maybe like getting into more meta stuff, but I'm just really curious about. There's a lot of interesting things going on in this story, but given that it was part of the Naval Research Laboratory, was it done under their funding? Was it done with their facilities? Like, do you happen to know like how much they were involved in that?
He doesn't speak a lot about it. I just know that they gave him a grant, they provided technical assistance and the equipment.
Okay, it's just interesting because it seems to contradict the idea that there's some sort of, I don't know, government or other forces, let's say, that are trying to suppress this kind of research. I mean, it's odd, don't you think, that the Naval Research Laboratory wouldn't try to prevent him from publishing this or anything of that nature, if indeed there is a broader attempt to prop up relativity as a theory. I don't know if anyone can comment on that piece specifically, though.
I mean, they do that to all kinds of stuff, bro. Almost every cool effect that I have found, the military's had their hands all over it and researched the crap out of it. And there's papers about it, but it just doesn't get talked about. I mean, like we went through the whole Biefeld-Brown effect thing. They had their hands all over that. How an asymmetric capacitor in vacuum can produce a net force enough to lift objects and carry loads. Like, that completely destroys no laws of physics, bro. You can't have a net force in a vacuum from a capacitor just supplying a voltage from one side to the other. Doesn't make any sense. And they'd even produced those results for like 25 or 30 years and measured them constantly all day, every day for years, and found that the magnitude of the effects had a periodicity that matched the motion of the sun and the seasons. Same thing that Dayton Miller measured. And they probably did that because they did it right after Dayton Miller's experiments. They probably knew to look for it. That's probably why they did it.
The Sagnac effect is a key part of the modern inertial navigation systems. The planes, the boats, all of the military missiles, they all use the Sagnac effect as part of their guidance system. And of course, GPS acknowledges the fact that there's a Sagnac effect, correcting for it, allegedly.
Naturally, although they propose that as a consequence of the rotation of the Earth, of the receiver relative to the satellite. Is that correct? Am I thinking about that correctly?
Yes, that's exactly. It's like the train, all right? Interpreting whether the speed of light is constant or whether the motion of the train in relative to the absolute frame of the Earth is dragging the ether along with it, which affects then the speed of light. So that resolves the simultaneity problem, because the speed of light is not constant for observers when there is a ether wind underneath it.
So even on the Wikipedia page, I'll even show it to you. I mean, Wikipedia is like mainstream and liberal, but even Wikipedia says right here under the Sagnac effect, the effect is a consequence of the different times it takes right and left moving light beams to complete a full round trip in the interferometer ring. The difference in travel times, when multiplied by the optical frequency, determines the phase difference. The rotation thus measured is an absolute rotation. That is the platform's rotation with respect to an inertial frame.
Oh, whoops.
Now, it's not the platform's frame that it's with respect to, right? Except in the experiment it is. You can't invoke any other frame because it's the detector measuring it where the detector is that's picking up the fringe, and the detector just so happens to be on the table. So unless you can introduce some substance that has relative motion in between the detector and the emitter, which are co-moving, there's no way to get a different time. It says right here, the effect is a consequence of the different times, and it is. But why is there a different time? Because in the co-moving frame, there's no change in path length, there's no change in time, everything's the same. C is C on the table, and the detector's on the table, so how can you have a fringe? This is why Sagnac made this experiment and stated correctly that it disproves special relativity, because it measures absolute rotation. And the inertial reference frame, the external, but just so you know, this is an external reference frame, inertial reference frame. That external inertial reference frame is absolute space, and it's the ether moving through absolute space, or the table rotating against it. Either way you want to say it, that's producing the fringe.
Did anyone ever try to edit Wikipedia?
No.
I did.
No. Yeah.
I did, and I tried it. Very interesting on this very topic, Sagnac. I submitted an edited change, and of course I based it on the analysis of Sagnac in terms of an absolute Lev frame. And what I learned is that there are gatekeepers. Edit, consider all of the suggested changes. And then it becomes like a legal process where you have to go through these different hurdles in order to get even the change that you propose accepted for review. So there's this level of bureaucracy, I guess, that delays. You have to be motivated, in other words, in order to pursue any Wikipedia change. What I found is they just, in response to my corrections, would simply say, basically, special relativity has shown that your point of view is incorrect. They don't give any proof. They just give one sentence replies. Relativity is correct. Special relativity is correct. And you get blown off. So I don't know if anyone else has that experience, but that's the way Wikipedia works.
That's it's like, well, this demonstrates that special relativity is incorrect. Oh, well, you're wrong because special relativity is correct. Like, okay, thanks.
Yeah, I think Toby had a similar experience when he was editing the Barbershop 2 wiki.
Yep, right, exactly. It's not a comedy. It's a drama.
He just wouldn't listen.
And one more thing, real quick, and then because I want to hear, but you might change what you're going to say before if you hear this first. I don't know, maybe you won't, but this right here, this loop, right? This is showing the loop unwound, but imagine that this isn't, all asymmetric or whatever. Imagine this is just part of the circle, right? And you got let's pretend instead of it being off over here, let's pretend you got the source right here and the detector right here, and they're part of this loop, and it's all just spinning, right?
Mm-hmm.
Here at the edge, which is where they are, they're right here. They're right here at the edge. You can't predict a fringe. What they do, as Alan told you that the other day in their papers to predict a fringe, is where it says A right here. They imagine an imaginary frame, a fictitious frame, in which there's a detector in the middle, because the detector in the middle at the center of a rotational reference frame, there's no rotation, right? It's staying in the same spot. And so since it's not moving, and this is moving, you're able to see that obviously there's relative motion between the two, thus you can predict a fringe. That's not possible here though, because they are co-moving. But this right here, the reason I said this is the same thing they do with the Earth and satellites, right? So imagine this spool, this circle, this loop is the Earth, okay? The Sagnac table is the Earth. The edge of the table is where observers are on the ground, or satellites are right above the ground. And the center of the table, which is the center of the Earth, is the center of the ECI frame, as the origin is the only point that's not rotating, that's not moving. So you can predict a relative motion between the edge and the center. So what they've literally done is took their brute forced fictitious frame explanation for Sagnac effect on the table and applied it to engineer a fictitious reference frame for the Earth with which to make satellite measurements so that they can have a reason to produce a correction.
I don't quite understand that point still. I don't know. The idea of this. So, Alan, I believe what you had said as it relates to this in the debate, I think you used slightly different phrasing than Piezo did, and I'm sure you're kind of saying the same thing. But you were saying that creates a preferred reference frame, and somehow through that we have an invalidation of SR. Was that the argument you made?
Yeah, if you try to derive the Sagnac effect using the principles of relativity, which is a constancy of C in inertial frames, relativity predicts that there will be no fringe displacement, because in the beginning of Einstein's theory, in the first page, he says, we're not going to assign imaginary velocity vectors or invoke absolute space to explain measurements. So The geometrically convenient position is doing exactly that. It's creating a spot in absolute space to extend to extend the motion so that it can be measured, right? So if it can't do that, then relativity predicts that it'll complete the circuits at the same time, which would lead to no fringe. So what they have to do, and also it would, even if it did predict a fringe, it would be much smaller because it's the square of the velocity over c squared. So it wouldn't even predict the full fringe, and that's a huge problem because this experiment is done where the fringe displacement exceeds what the refractive index value would be. So like in the case of Fresnel, where it's 44% of the velocity, in addition to the refractive index, these fringes exceed whatever refractive index that you could attribute it to. So it's not possible to explain it under the principles of relativity. You have to invoke a quote geometrically convenient frame to then explain it to the full amount, which nobody,
like the center of the table.
Right.
So that's interesting. So there was a commenter. I don't pretend to understand this super well. This gets extremely technical as it pertains to this portion specifically of the Sagnac effect. But did you see that comment? I think, what was it by, some guy with a G in his name, Alan? I sent you a couple papers. Maybe we could discuss that. Jeems or something? Jeem?
Oh, yeah, we're going to read those on Thursday. We're going to read them live.
Oh, excellent. All right, so let's wait till Thursday then.
Cool.
Don't want to spoil the punchline on that one. And then
Nice.
I'll have some more time for some time to read it. Is that going to be like a round table, like one of the research paper events or something?
Yeah, if you want to go.
All right, cool.
Or let me give you the super short and sweet, just see if it makes sense. Where in this, so see if you understand at least this, where in this actual experiment, where are the measurements taken? In what location are the measurements actually physically taken?
I'm assuming at the detector is not the right answer.
No, that is the right answer. The measurements are taken at the detector. It's not a trick question.
Okay.
Right? So that's where the measurements happen, right? So the fringe is produced and measured where the detector is. Right? Yes.
I mean,
yeah, the answer, it's not a trick question. The answer is yes.
Right.
Okay. So that's where the fringes happen, and that's where they're measured. Now, the explanation, in order to be able to predict a fringe, because as Alan's telling you, special relativity predicts no fringe, that's because the detector and the emitter have no relative motion between them. If there's no relative motion, then there's no fringe. In order to try and explain the fringe, they fictitiously place the detector at the center of the table. So they take measurements in reality right here where the detector is, but then they're like, okay, well, the prediction to make the fringes happen by math is by placing the detector which is the observer, in the center of the table. So they just do a quick little whoop, pop, and then put it right there in the table center. And they're like, okay, now we can predict a fringe. Do you see why that's a problem in reality?
Well, yeah, I mean, it depends on how you structure things, right? I mean, at the end of the day, you're deriving the effect based on a model, right?
Based on a measurement.
No.
Well, sure, on a measurement, but predictions are based on models, are they not?
Well,
yeah, and if you try to predict the fringe based on the modeling of relativity theory, it makes the wrong prediction. Because you can take this to an even more extreme position.
Not if you adjust the model, assuming that the statement of that is correct.
You
I don't
can't
have a great basis to comment
you can't
on that,
adjust
but-
the postulates of relativity, dog. Like it's over.
No, I'm not saying
And
that
then-
you are.
No, I'm saying
Sorry,
you
go ahead.
can't. So it gets even worse though, right? Because this is just an example here of a fiber on a rotating platform, you could say, right? But the Dufour and Prunet experiment, they have the detector fixed to the lab wall and the source fixed to the lab wall, and the only thing that's rotating is a bottom platform that's attached to a motor. And using 45-degree angled mirrors, it reflects to that from a stationary platform above it to a rotating platform under it, and then it recombines back to the top platform, which goes back to the lab wall, and the full fringe is measured. So we have like the ultimate no relative motion inertial frame measuring a fringe that's directly proportional to the rotation of the table, which is again not possible in the relativistic paradigm. That's when Paul Lavue came in and was like, or I'm sorry, Paul Croissant comes in, and he's like, hey, let me invoke this geometrically convenient position at the center of the table. And even when you do that, it makes the wrong prediction. It's off by a factor of 10.
Yeah, because he can't retain the same distance between the emitter and detector unless he like places the table in some weird location where they're the same distance apart. But yeah, it's
so it's like you have to assign absolute space, then assign imaginary vectors where electromagnetic propagation once took place, right? Which is all against the core of relativity theory.
And the other problem is, even if you were right and you can just make a model that can model it with the prediction, the problem is how do you test it? Well, you would have to test it by putting the detector in the center of the table. But that completely changes the experiment. It's a different effect at that point. Like, the whole point of the experiment is that the detector and emitter are in the same inertial frame. If you put the detector in the center of the table, then they're no longer even in the same frame. So you have one that's at stationary and at rest, and one that's like rotating around it. So it doesn't, like, it has no basis on reality to make a fictitious frame where the detector's centered in the center of the table. Like, that's their best shot. Like, that's literally it. As sad as that is, that's the best that they've got, because there's just no explanation for it.
So, I mean, I'm hearing a lot of things like fictitious, convenient. It sort of implies a certain level of intent.
Of course.
Is that like, so do you like, what is your basis for that statement?
Okay. My basis is this. Is the detector in the real experiment in the center of the table? Yes or no?
No, but I'm just curious as to what it seems to me that they develop a model, and to be honest, this is outside of my depth of my technical training at the moment, but it would seem to me that they derive a model if your statement of the setup and like a special relativity explanation of the phenomena is true, that explains it. I mean, does this go back to Langevin? Like, who is the one that developed this geometric convenience, as you call it?
It's in several papers. What's the one that's like the 14 meta, like the meta overview?
Yeah, so Paul Croissant was the first one that came up with one using general relativity. He was basically saying that, when you invoke that center position, you're good to go. He was the first person to come up with a way to come up with the solution, right? Because Einstein never talked about Sagnac. No one talked about Sagnac for like 8 years. It wasn't until like 1917 or 1918 that Paul Croissant came through and was like, yo, check this out. If we use general relativity and we invoke this geometrically convenient position, we can say that link contraction and time dilation, we can take like the energy of the rotation of the device, turn that into link contraction time dilation to get the proportional rate for the what do you call it, to predict the fringe pattern. So yeah, I think he was probably the first, because that's what they went with for a long time. And then nowadays, after Dufour and Prunet, I don't know what happened, but nowadays most people will tell you, oh, rotating frame, special relativity doesn't apply, even though special relativity claims to have dominion over Thomas precession, which is a rotational frame. There's different ways that you can use rapidity to make a correction angle, or two Lorentz rotations to make them line up so that you can do a single Lorentz transformation so that they're orthogonal to one another. You can do integrals. Like, there's tons of ways you can incorporate rotation with special relativity. But when it comes to this, because it's a direct refutation, most people say that this falls under general relativity or special relativity has no dominion over rotation, when it does for other phenomenon that they claim to be able to explain with it. So it's like the weird special pleading they make.
Yeah, and
So
even doing that, they have to take the center of the table to put one of the devices, because if they use the actual experiment as it was performed in reality, then even if they apply length contraction and time dilation, there's an equal amount for both the detector and emitter, since they're in the same moving frame, so it still wouldn't produce a difference. So they have to put one in the center of the table so that there can be a differential.
So I'm looking at a paper now. I don't know if you've seen, I think I sent this one to you, Alan, as well. But this is one of the first papers I've looked at. And then there's a section. So this is, let me just send you the citation real quick.
Have you read it?
Not completely. So if that's, I'm just looking through it now. So if that's a problem, then we can talk about it later. Let's see. Oh gosh, why did it format that way? It is GB Malakin from the Russian Academy of Sciences, 2000. I posted it in the chat, but it got. Let me put the actual paper. I want to understand this preferred frame, and I still don't understand it fully. So it would help me to go through this paper. Because the interesting thing about this paper is it posits that there are correct and incorrect explanations of the Sagnac effect. So it lists 3 correct explanations and conditionally correct explanations. Actually, with an have you heard of the relationship between the Sagnac effect and the Aharonov-Bohm effect?
Well, the Aharonov-Bohm effect is it's kind of like Sagnac, but where it's kind of like a Dufour-Prunier, where the emitter and detector are stationary, or the electron paths are stationary, and the table's rotating. In this case, the table would be the A field, or the ether is rotating, because the solenoid's driving it into a rotation.
Okay.
But yeah, they try to say it can only. It's crazy, and I don't want to deviate from the topic, but just so you know, the Aharonov-Bohm effect, they say it's not actually caused by a like time differential of the electrons, like arriving at 2 different times, because the path length is the same, and they don't have any real forces that they can account for in their model. They say it is a phase difference in the probability amplitude function, the wave function. Even though like a phase difference in a real wave is a timing difference based on a speed change. So it's like they don't have an answer because there's no physical mechanism for them to explain a non-zero force. So they invoke quantum weirdness on everybody.
Well, I mean, appeal to quantum weirdness fallacy, So what else are you gonna do? No, I'm kidding. But I don't pretend to understand the Aharonov-Bohm effect and the quantum explanation. But I'm just curious. So this paper here, so it has, like I said, there's correct and incorrect explanations that it lists. And so it goes through. I think it goes through all of them, but let's see how many it goes through. But it has a specific. Okay, so I see what you're sharing now, Piezo. So Formula 13. SRT complied to a rotating sphere. Sagnac interferometer does not predict the Sagnac effect. The Sagnac effect being the fringe shift, right?
Yep. Yeah, that's like if you go all the way back to Sagnac's original paper in his original work in 1911, 1912, and what he did, he literally just uses the special relativity formula, and he uses the frame of the table that the devices are on at the rim, and since there is a no relative velocity between the two, then the v term is 0. So you just get like the square root of 1, which is just 1. So you just multiply each number by 1. So you just get L over C and L over C, and you get L over C minus L over C equals 0. So there's 0 fringe predicted by special relativity on Sagnac.
Yeah, I think so. I think, do you mind opening, since you already have your screen open, do you mind opening the paper that I sent you? Because I would like to talk about
the
it.
one that you just found and haven't read through yet?
Well, you want to read it together?
Yeah, just do it real quick.
I didn't just find it. I've had this paper on my desk for a while.
1 second. Correct explanations. Sagnac in relativity theory, Sagnac in general relativity theory, special and general. Methods for computing it for EM waves and anisotropic media. Main result of the analysis of the Sagnac effect in the framework of relativity.
Correct. So if you go to page number 1231, page 3 of the document. Let's see, where is it? Yeah. Oh, cool. Save my highlighting. Sweet. Problem is not so simple as it appears at first sight. The fact is the device recording the interference produced by counterpropagating waves fails to show any changes in the pattern. That would be the fringe shift, right? At a constant angular velocity and monochromatic harmonic oscillations being studied, records a constant phase difference between the counterpropagation waves. It's difficult to draw a definitive conclusion about their velocities. So I think that's what it's talking. I believe there it's talking about the difficulty that you're describing within special relativity, right? I could be wrong though. I'm pretty new to this topic, but then see, it has the propagation time difference, equation 4. And then if you go down though, this is the interesting part. If you scroll down to the bottom of that page, I think this is maybe exactly what you're talking about with the fictitious thing, as you put it. In order to calculate a phase difference attributable to the Sagnac effect between counterpropagating waves at the exit from a ring, it is more expeditious to pass to the co-moving frame of reference K prime rotating together with the interferometer. This is necessary for several reasons. Firstly, the interference pattern is recorded by a photodetector or imprinted on a photographic plate fixed in the frame of reference attending rotation. In fact, interference fringes are already apparent at the bleed splitter of the ring interferometer. Second, in the laboratory stationary system of coordinates K, the beam splitter serves as both the source and actually the detector of radiation, and besides is in motion. This may lead to a completely inadequate conclusion such that the classical Doppler effect takes place in such a situation. The passage to the co-moving frame of reference K prime attending the interferometer rotation, where the beam splitter of the ring interferometer is immobile, obviates the necessity for considering this question here. So I think that's explaining why we moved to that frame. Am I wrong though? Because as I said, I haven't really looked into this very much.
It says where V is the frequency of radiation in the frame of reference K prime if the source is located at a distance R from the center of rotation.
Yes.
So yeah, so I don't know because I haven't read this, but the fact that they're referencing a center here is curious to me. Because I think in his...
Oh, here's another interesting thing. To explain what you're going to say, but I just found another cool part of this.
Okay.
So if you go down to just above equation 7 on the right-hand side of page 4, in expression 2, see where it says section header 2.
Yeah.
In expression 2, we use the relativistic law of the composition of phase velocity and the ring rotational velocity r omega in a correspondence with the opinion that the Sagnac effect constitutes an STR effect, based on citations 10 and 11. It will be shown in section 5.2 that the application of the Galilean law of the velocity composition to the consideration of the Sagnac effect for waves propagating in material media leads to the erroneous conclusion that this effect does not show itself. So what is that saying?
1 second. It's saying that Galilean law of velocity composition, such as like, c plus or minus v, and considering the Sagnac effect for waves propagating in material media, leads to the erroneous conclusion that this effect does not show itself. Now, I don't know what they're referencing because it happens in,
Yeah, can you're like you're hovering it. Yeah, cool.
I don't know.
It shows in air, which is a media. I mean, it has a refractive index very close to 1, but it's still technically not exactly 1. It happens in water. It happens in prisms because there's people that have done it with.
He's saying that the special theory of relativity is not being shown is the conclusion of that paragraph.
Yeah. Oh, you're saying. Hold on.
Not sure. I think it's saying that
It corresponds with the opinion that the Sagnac effect constitutes to an SDR effect. It will be shown in section 5.2 that the application of the Galilean law of velocity composition of the consideration of the Sagnac effect for waves propagating in material media leads to the erroneous conclusion that this effect does not show itself. What effect? The SDR effect, the special theory of relativity effect.
Yeah, but he's saying that the that conclusion that it does not show itself is erroneous.
Well, is he saying?
I guess here's the thing, man. I don't so I understand what you're saying. It seems like this paper is saying the same thing. It's saying that it's expeditious to pass to the co-moving frame of reference K prime for the purposes of making the prediction. But I don't see a problem with that. I think that you have an interpretation that it's geometrically convenient, but I think you interpret that in a light that I wouldn't. But I don't know if Dr. Bennett has any feedback input here. I'd love to.
Why can't they predict it from the actual reference frame of the actual experiment?
Yeah, real quick.
Well, it's a question of.
Real quick.
Yeah, go ahead, Alan.
C plus or minus V makes the correct prediction. Like the classical equation makes the correct prediction with no additional requirements, right? It just is what it is. What the problem with relativity theory, right? Specifically, Einstein states that he doesn't need to invoke absolute space to explain it or assign imaginary vectors where electromagnetic processes once took place. And then later in his paper, he goes on to say explicitly where his equations apply, and he mentions any closed polygonal circuit in uniform rotation. So he actually double set up for the traditional Sagnac effect on the rotating platform. That's why Sagnac was like, "Yo, I bodied you, son." Now, it doesn't matter if you can transform to the center of the device and then make the prediction. You'll notice they're not using link contraction and time dilation because those make the wrong prediction. They're invoking the geometrically convenient position because they have to assign imaginary vectors for where electromagnetic propagation once took place, because that's the only way they can make the full quote unquote prediction for the fringe. It's violating the core postulates of the theory of the constancy of C and where the equations are supposed to apply in the relevant reference frames.
That's why they initially. Oh, go ahead.
Yeah, let's look at section 5.2 here. I think that's talking about that.
Well, before we do, real quick, so this paper seems to be saying the same thing as the this is like a different meta paper than the one Alan already has and found, which it's another one that goes through like 14 different explanations and settles on the invocation of an imaginary frame that's not actually on the table. It's like somewhere else, or it's not actually where the detector is. It's somewhere else. And it says like, even though we can find some frame somewhere and define it in just the perfectly right position, depending on the conditions, in order to try and predict a fringe, the explanation of the physical fringe actually produced in the experiment remains difficult. So they're like, yeah, well, we can predict like a fringe for some imaginary frame where the measurement wasn't actually taken, but the actual real measurement that was taken on the real table in reality, we still can't.
Yeah, we can go to a higher order and make the math work, but we still can't even physically explain it, and we don't even have to go to a higher order if we just accept the classical explanation.
Yeah, that's what he's saying here. So he's saying that luminiferous ether is applicable only to the computation of Sagnac, right, with EM waves, light. And the magnitude for arbitrary waves in the most general case is more appropriate for assessment by means of classical kinematic calculations based on the estimation of rotation-induced displacement of the beam-splitting mirror at the entrance of a ring interferometer during the time needed for counterpropagating waves to complete their time around the ring. Also, the Galilean law of velocity composition with the linear rotational velocity may be used. And at first sight, this approach allows the Sagnac effect to be computed not only for electromagnetic waves, but for waves propagating in a material medium.
Yeah.
So, like, he's basically saying it's just classical mechanics that works.
Yeah, but this is classed under his section 5. Section 5 is incorrect explanations.
Well, I mean,
we make the correct prediction, dog. Like,
Well,
he can say
mean,
whatever the fuck he
oh my God,
wants.
guys, maybe this is just a difference of opinion, but
Nah,
it
it's
doesn't
not
seem
though.
to me to be a problem. It doesn't seem to me to be a problem that they're invoking a particular reference frame.
Bro, the only reference frame that matters for predictions is the one in which the measurement's taken. Like, if you invoke an imaginary reference frame for a thought experiment and say, well, based on our math, this is what the fringe produced there would be. It doesn't, like, how do you even prove your thought experiment's correct without going and measuring it? Without measurement, you're just doing thought experiments, dog. You need a measurement. And that's the problem with special relativity. It can't predict a fringe where the measurement is actually taken.
I still don't see the issue.
You don't see an issue that it can't predict a fringe where the measurement's taken?
It's all
on
good,
the base,
dude.
no, I don't think
We're
it's an
beating a dead
issue
horse.
that we invoke. I mean, if we're going back to this paper, and I mean, you guys obviously have done a lot more reading on this than I have, so I don't mean to discount your experience, but I mean, it states pretty clearly here that the move to a co-moving.
Well, hold on. You can discount our experience all you want. We're talking about facts. Let's just be real clear about that.
I mean, at the end of
Don't
the day,
worry. This is not about experiences. Just keep going. You're good.
Was that a yes to my question then? Like, you don't find it a problem that you can't predict a fringe where the real measurement's actually taken?
No, not as you phrased it. No, I don't see that as a problem.
So shouldn't a working theory that's accurate be able to predict a measurement that's real?
It is. It's just invoking a different reference frame for the purposes of making the prediction.
Is the measurement taken in that reference frame?
Well, it's produced by the light moving through that reference frame.
No, it's produced by the light moving through the real reference frame through which the real measurement's taken.
What's the real reference frame?
The table.
Why?
Because that's where it happens and that's where the measurement's made.
Okay, but I'm just telling you that I don't personally see a problem with this. I mean, I do modeling all the time, and when we're talking about this, I mean, I'm not a special relativity guy by any means, but it doesn't seem like there's anything fishy going on here as far as I can tell. I mean,
I got you, Brody. I got you, Brody.
Of moving to this frame of reference, and then once you do so, the predictions shake out. So what's the issue?
I got you, Brody.
Gentlemen.
Sorry.
Gentlemen. Yeah. Oh, I lost the screen.
I was giving it to Alan.
Yeah, I want to hear. Maybe Dr. Bennett can set me straight.
I need the screen to see the
sorry.
the text.
Yeah, I'll bring it back up. What do you want this text or something different, Dr. Bennett?
No, the screen you were on, where in the second column it was 5.2.
Yeah. Okay.
Yeah.
It's there. You just got to click on the thing again. Sorry about that.
Oh, let's see. Wait a minute. I can't see the text unless I zoom in at 300%.
Yeah, one second.
Can
Let
you
me
zoom
change
in,
the zoom.
Piezo?
Yeah.
Or, Alan? Cool.
Can you see it now?
No, I got it. Do I have to
click
join
on it.
again?
No. Maybe you don't have it full screen because if you
you could try clicking on it twice. Actually, that might work.
Well, anyway, I know what it looks like. The section you're looking at, which is probably the only line I can see because it's in bold. 5.2, what's the last word?
Sagnac effect from the standpoint of classical kinematics.
Kinematics. Okay, so that section is talking about measurement, not prediction. It's not talking about mechanics, right? What is the standard you're going to be using there? Well, whatever you measure is what you measure. That's the result. What we're looking for is a prediction, that is, of dynamic laws of physics. That's what the Sagnac is intended to do. So just looking at the title of the section, it's not appropriate to discuss whether the Sagnac effect is correct or not. You have to look at dynamics, not kinematics. And that's basically what I've been preaching since the beginning. It's in the absolute lab frame of dynamics that the conflict arises between relativity and ether models.
So Dr. what would be Bennett, are you saying that a theory or a model is only useful insofar as it's able to match its predictions to physical measurements?
Of course. That's what the scientific method is.
I would tend to agree with you.
You test your theory with what? Experiments. In other words, you test dynamics with kinematics.
So what would be your basis for the dynamics in this example, Dr. Bennett? Like, I'm not an expert like you are, so I don't have a good basis, in fact, to describe that.
Oh, like you said, you need a model, right, to test. I agree with you, Morty, on that. The model we're testing is relativity versus ether, basically. And the Sagnac effect, as the author stated in the experiment itself, he concluded that the change in the speed of light was due to the ether drag of the rotating platform, and that caused the value of c to change to c plus v, meaning that the speed of light must be measured relative to the ether frame as measured from the absolute frame of the Earth. In other words, the ether must be included, if it has any motion, in determining what the speed of objects is in that ether. And I don't know, that's all I need to say.
No, that's helpful. Thank you for clarifying that for me. And I guess that resolves issues with the Maxwell equations, as we were mentioning earlier, in your view, with the speed of light, because you still have a constant speed c, but then it's additive with respect to the ether. Is that correct? I don't want to mischaracterize your position.
My position is that you should use the Maxwell-Hertz equation. You've probably never heard of that, but that was proposed by Heinrich Hertz, and it includes the speed of ether in the model. The value of that is that it's covariant. That is, you can use Maxwell-Hertz equation whether you're in motion with respect to the lab frame or not. And the proof of that was by Thomas Phipps. I'm going to provide a copy of that from my book. Once I finish copying it, I'll post it on Discord. And its significance is that it shows that if you're in any frame of reference, you can use the Maxwell-Hertz equations, and you will correctly predict the laws of Maxwell. I don't know if you've advanced in your studies yet, Morty, but there is something called the Faraday anomaly, where the Faraday's law of induction does not hold for two cases, where the electric field is not rotating with respect to the Earth, but the magnetic field is, there should be an induction effect, but there isn't. And then there's another anomaly, also referenced by Einstein in the first paragraph of the 1905 paper, where he alludes to the anomalies in Maxwell's theory. And so you may not be aware of it, but Maxwell's laws are not complete. Faraday's law specifically has 2 violations, and they have not been explained except by an ether model. And I can give you references for that.
Oh yes, please do. I'd love to read them.
There's a video.
Well,
there's a short video that Alan has. You can ask after this. Like 5 minutes. Sorry, Dr. Bennett. Go ahead.
No, that's all I have to say.
I think you meant Galilean invariant, not covariant. By the way, you said covariant when you were explaining it, but I think it's specifically that it's invariant.
Well, it's 2 definitions. Galen raised this issue. There is a researcher at University of Pittsburgh called J.D. Norton. He has written prolifically on the topic of covariance and invariance. So he's a recommended source. And then there's Phipps, who also defines invariance and covariance, but in a different way. Let me define the 2.
Okay.
Invariance means that when the value does not change when you change reference frames. An example of an invariant would be mass. Mass does not change when you go from one Galilean reference frame to another. Covariance means that the form, not the value, the form of the equations remains the same. An example, F equals ma. All right, that's in, let's say, the X frame of reference. F prime equals M prime A prime. That would be a covariant expression if you used a different reference frame. But what you will find is if you change reference frames, that there are additional terms that come about, just like when you go from Cartesian coordinates to polar coordinates, then you get R factors that are due to the metric being different. If F prime equals M prime A prime is the same form, in other words, it predicts the same results as if you're in the F equals MA prime, and that's called covariance. So obviously we want only physical laws that are covariant. We want laws that we can move to another frame of reference with an observer moving at a different speed with respect to us, and he can apply the same laws in the same form. So covariance is a very important concept. And as I said, Phipps has shown that Maxwell's laws are covariant if you include ether. If you include a ether wind, a V ether, or a VA.
Sorry.
Go ahead.
Are you saying so you're saying that invariant means like the actual number values, like in like the force value, the mass value, the acceleration, like the values themselves aren't changing no matter what. Covariant is saying the values themselves may change, but the equation used to calculate them won't change. So you'll get like an equivalent result just with different values.
That's right.
Okay.
You get different values, but you get the correct prediction in the prime frame.
Right. Okay.
Right. And you get the same prediction in the prime frame as you got in the unprime frame. So, for example, if you were looking at I don't know, an eclipse, right? And you're looking from the Earth's point of view and the sun's point of view, okay? You would have to do a transform between the two. Okay, you cannot have one vision, one model thinking that there is an eclipse and the other one that there's not an eclipse. I mean, it's like the train experiment, that, right? The lightning. You can't have one reference frame saying there is an explosion, the other one saying there isn't. You can't have in Newton's bucket, you can't have one observer saying the water surface is flat and another observer saying, no, it's curved. It's only one thing. It's curved or it's not. It's not both.
Yeah, it wouldn't be covariant under transformation.
Yeah, but what you said is correct. Invariance means value is constant. Covariance means the form of the equations is unchanged.
Thank you. That's a super simple explanation. Is that what Phipps is saying in his paper when he says that the Maxwell-Hertz laws are invariant? No.
Well, he uses invariant for both situations. So I use Norton because it's important to distinguish between when values are constant and when the form of an equation is constant. That's an important distinction. And for some reason, Phipps calls it invariance, probably because he's such a high-level mathematical thinker that he identifies them as both invariant in some mathematical sense. But J.D. Norton is the one. Yeah, look at Norton and you'll see the explanation.
J.D. Norton. Write that down, Alan.
Easy. I already put all of his PDFs in the main chat.
So when Phipps is writing about the Maxwell-Hertz equations, which are not well known, I do remember in his paper, and maybe you can explain this to me because you made a lot of sense out of what you just said. That was great. Thank you for that. I remember him saying that he's drawing a distinction between the invariance and covariance, and he's saying that like the Heaviside formulations of Maxwell's laws that Einstein used are covariant, but the Hertz is invariant. So what is the difference under him? Like, what is he saying the difference is if he's using different definitions?
Well, he's basically using the term covariance or invariance rather as a blanket that handles both, a blanket description of both situations. I think rather than discuss that, I think it's important to realize that the equations being covariant, excuse me, having a proof of that covariance is one of the most unnoticed events in history. In other words, buried in this 600-page book that he wrote is this reference to the proof of covariance of Maxwell-Hertz, meaning with ether. And I don't know of any reference that I've ever seen. I mean, I came across this because I bought the book because it was recommended, and I found this. But other than that, I haven't seen any references to it. And of course, the guy has passed away, so he's not capable of promoting it. So
by a proof, you mean like an experiment with a measurement, right?
Yeah, I would say of the 5 most important things that I've discovered, definitely this is one of the 5. The covariance of Maxwell's equations when ether is added.
And the difference in the Maxwell-Hertz is Hertz used the A term, right? The A field, the vector A potential.
Well, actually, what Phipps used was he used a velocity of an underlying space. You know, have you ever been to an airport where they have a moving sidewalk?
Yeah.
Okay. Well, when you get on the sidewalk, you can say, well, I'm moving at a certain speed, but actually you're not. To somebody not on the sidewalk, you're moving at your speed on the sidewalk plus, I mean, it's the usual C plus V, right? It's Galilean addition. So he assumes that there is a underlying velocity, which I don't think he identifies as the ether, but corresponds to his definition of what the VD means. And he shows that makes the Maxwell's equations covariant. I'm going to try and simplify the proof. And when I send copies, I'll include comments about it. Because, as I said, it's in my top list of 5 as most important discoveries outside of what mainstream science believes are the most important. Newton's bucket interpretation, of course, is another one. The Wang experiment is another one. And I guess I could add 2 if I think about them.
Wow. So you're making another book. Do you have any? I still need to buy that Galileo was wrong, the church was right, or whatever, so I can put it in my backpack and read it when I'm killing time in the library or something. But
no, don't buy it. I'll send you a PDF, and that will include visuals, graphics, or the astronomical motions. And with the PDF, of course, you can edit it and clip off whatever you want. I think.
Okay.
I think Alan has a copy, right?
Yeah, we've got a copy. Yeah.
Yeah. Okay. So just give
we can
him a
hook you up,
link to it.
Piezo. Yeah. If you're on Telegram, it's on there. Actually, it's probably in Docs on here, honestly.
Well, looking forward to your new book, because I expect that this one is going to be a more in your face, like, here's my direct proofs for ether. So I'm really looking forward to that.
This isn't a new book. I'm just going to copy the proof of covariance for Maxwell-Hertz equations. I'll do some comment and explanation because some of the notation is kind of strange, but it could be the basis for a general book, but that takes time.
Yeah, well, we definitely need you to pass on all your knowledge before you retire for good. Before you decide that you don't like us anymore and you want to just go move to an island somewhere and drink martinis on the beach.
As long as you have enthusiasm for the topic, hopefully I'll be around. I had 2 close friends who recently died, and they had knowledge of alpha. They were both physicists. One you may know, Wolfgang Smith. Have you ever heard of him? He's a philosopher. He's written several books.
I haven't, but
Anyway,
I'm not good with names. Alan's better with names than I am. I'm the person who looks at the papers and doesn't know anybody's names.
Anyway, these 2 guys knew alpha. They understood it, and they encouraged me to promote it. But they're gone. They can't promote it anymore. The only way I can promote it is through the internet and hope people read it, or through you guys who hopefully can accept whatever I say and prove that it's right, because I'm not claiming that I have any divine knowledge. I'm only going with whatever God-given logic God gave me and analyzing experiments in accordance with that. So basically, if I'm going to promote the alpha model, it's basically going to have to be through, as I said, through further books on the internet or through promotion through Aether cosmology or other online ways of promoting your ideas.
Son Genesis' next movie, yeah? His next documentary?
Yeah, he's doing an analysis of Genesis 1. He's doing each day and interpreting it with scientific theory, which of course is geocentric. His model is general relativity. He accepts general relativity with ether as the explanation for the curvature of space. So it's a little different from me. I don't accept general relativity, but I accept Galilean relativity with ether as the underlying platform, as I indicated. I invited him to the debate tonight, but he, like I said, he didn't answer, so I assume he has other plans.
Yeah, he might not want to try to. He might feel like he doesn't want to bear guilt by association. I don't know. I mean, I can't.
Hey, it doesn't bother me.
But I don't know that I'm excited to hear a massive universe try to be co-opted onto the idea of a firmament, because I have no idea where he's going to put the waters above from the flood. But hey, I guess we'll see, right?
Yeah, you can get the. Let's see, what is the firmament? That's day 3, right?
Day 2.
It's on day 2. Yeah, I think he just came out with day 2. I mean, he's taken a month or 2 for each chapter or for each day of Genesis. So he's really going into details. And when he goes into details, there's a lot of details.
Word. Well, I don't want to take away any more of the conversation from everybody else here. Thank you for discussing that little sidebar with me. But it was very relevant as far as the Maxwell's equations go. And did that answer your question, Ward Wand?
Dr. Bennett answered questions that I didn't even know I had. So yes.
That's the best kind of answer.
Cool. Well, it's getting a little late. Do we want to, like, any final thoughts anyone wants to throw in? Do we want to maybe start wrapping things up here?
Do we maybe want to watch the closing statements in light of what we just talked about? Because I think we clarify, for me, a lot of what was talked, like in a debate, it's like, obviously you're under pressure and you have limited time. I didn't really get enough of a appreciation for Alan's argument regarding the Sagnac effect. I feel like I understand it a lot better now. So maybe we just watch the closing statements and then get thoughts from Dr. Bennett on the overall structure of the debate. I don't know. What do you guys think? Because those are short.
I think we pretty much already covered all of it.
Okay, up to you guys. Yeah.
Let me bail out at this time, but I have made notes which have timestamps on them, and so I think if I just put them on Discord, everyone can look at them and get my opinion of the details in the debate. But other than that, I think it's bedtime.
Nice.
Bedtime for Bennett.
Yeah, that
This has
works
been
out perfect.
fantastic. Thanks for suggesting this and for spending this time with us. This has been really great.
Yes, sir. And by the way, Dr. Bennett, I know you're not super tech savvy, but if you ever get the opportunity to click on the very top left button on Discord where it says direct messages, I've sent you a few of them. I'd love to chat with you like when you have free time on there.
You gotta email him.
Oh, yeah. Dang it.
Yeah, email is much better because I think I've only had 6 direct messages, and I don't look at them unless I get a pop-up warning from Discord.
Yeah, and I emailed Dr. Bennett and he responded right away. So I appreciated that. He's prompt with the email. And yeah, I concur so much, Dr. Bennett, for your time and your feedback and your insight on these matters.
Yeah, and as far as our email communication, if you want to not debate but discuss anything, do it through the email.
Okay, sounds great.
You have a website, right? Because I got your email from Alan, but I'm trying to remember. I'm sure it's on your website as well.
No, I don't have a website. I have a YouTube channel with a few primitive videos that I made, you know, turning PowerPoints into videos. No, I don't have a website, but I post my my research on Vixra.
What's your
if you do,
website or your YouTube?
Gotcha,
my
I'll send you a link
YouTube
in a
is
second.
He's got his email
Yeah,
address in all his papers. Sorry to interrupt.
yeah, that's right.
So that's just one really easy way to get it.
Alan's got your YouTube. He'll give it to me, I'm sure. Okay. Sweet. Because I've typed your name on YouTube before to try to find you, and I'd only see like Witsit's video of you pops up, and then a bunch of random Robert Bennett's that aren't you pop up. But
yeah, it's only a few little videos
in the main
that I made, which was just really practice. Most of the research is in Vixra, and you can find it by going to Vixra and doing a search Robert Bennett archive. And then you'll get all of the documents that I posted.
Ooh, Sagnac completed by Dufour and Prunier, Faraday's paradoxes. Yeah, this is definitely you. Newton's bucket.
And it's not it's not just physics either. It's math and some religion too. So okay, I'm going to bail out, but I promised you that I would post on Discord the Phipps copy of the covariant proof. And what else? Oh yeah, I would post what remains of my notes about the debate.
Thank you very much, man.
Okay.
Much appreciated.
All right. Good night, guys.
Later, G.
God bless.
Have a good night, man. Appreciate it.
Much love. Thanks again.
I think you guys mean Dr. Cassander. I don't know who this Bennett character is you all are referring to.
Dr. Cassander, that's right. The kind of prefer Super Cassander, honestly.
Where does Cassander even come from? Where's that from? I wonder.
Couldn't tell you.
Well, cool.
But,
should we wrap streams up here then?
Yeah, dude, I'm getting a little fatigued, man. Like this was a long one, but luckily I was able to hit up some.
I legit am a little fatigued. It was kind of a long one.
Some caffeine would help, actually.
Dude, some
Even though I don't consume
caffeine.
it.
Some caffeine would help.
That old midnight cup of coffee.
Yeah, midnight cupper.
Are you looking to dive in tonight? Are you gonna dive into some covariance and some invariance? Are you gonna start looking through this? What was it here? We've got the Einstein, Nordstrom, and early demise of scalar, Lorentz covariant theories of gravitation. Did Einstein stumble the debate over general covariance? general covariance and the foundations of general relativity, 8 decades of dispute. Man, this is a lot of Norton to read. But you know what? We can't just let these relativists just skirt on by. We got a lot of reading to do. So what do we got to do? We got to start that cup of Midnight Joe. So that means you start your hot water, go to, let's say, 195 degrees. You know, if you got an electric kettle, that might jumpstart you a little bit there. And then what are you going to do next? Well, you're going to grind your coffee beans. And obviously, they are brush-tail coffee beans, because you're not going to just start reading some John D. Norton on some Folgers, or I got Stumptown coffee. Ooh, I'm so cool. No. You want some good single origin coffee that was roasted recently and isn't run by some some corporation in Portland that's pretending to be a small company. How about the guy, this dude that's talking to you is marketing the company. He's roasting the beans. He's managing all those crazy employees, aka himself. I mean, come on. You can't get smaller than that. I mean, you could maybe go to like a kid that roasts coffee.
We get
That's
a plank length
technically
on that?
probably smaller. Yeah, like yeah, what did you say? Baby penguin coffee?
1 plank length?
One plank length coffee. But anyways, yeah, so you should drink brush-tail coffee. You will become a genius. You'll understand all these Norton papers, these John D. Norton papers. You'll also understand Nordstrom Rack, because I almost said Nordstrom by accident. So there you go. It's been known to cure blindness. No, that's not true. That's all alleged. It's all jokes. But really, it's good coffee. It's single origin, and I pick it myself. I roast it myself. I love it. And if you like good quality coffee that's roasted fresh, then you might also love it. Give it a shot. Even if you don't like good coffee, maybe you've just never had coffee that's actually good.
Good pitch, sir. But the question is, Toby, will you guarantee?
All right, lads, check us out tomorrow. Shane and I will be hosting the weekly community sesh on Wednesday. And then we'll have reading night on Thursday. We're going to read over some of the papers that Mord brought up during the debate. And then Friday, of course, will be Flat Earth Friday.
I think this coffee is going to do way more than keep you up. You want to hear my latest testimonial?
Yes.
Hold on, we gotta.
Yes.
Hold on. Before, just a little bit. Brush-tail coffee does not actually provide any health effects or any health. There you go. That's the disclaimer.
For entertainment purposes only.
there
nice. Thank you.
Thank you. That's what I wanted.
Oh, well, okay. So I used to have really, really bad turret syndrome. I mean, it was so bad. I used to go to the pub, and those sailors there, the drunken sailors, they used to blush. It was so bad. And then finally, like they would get so drunk that they would pay me to have these little fights with each other, and I would, whoever paid me the most, I'd get on their side, and I would just go full on with my turret syndrome. I mean, cussing like nobody's ever heard before. And then I started drinking brush-tail coffee, and now I'm cured.
Wow. That last roast you ordered, I guess, they were really good beans. So I guess, you never know what's going to happen.
Oh yeah.
Thank you for the story.
You're very tasty, the Ethiopian.
Wowza, that reminds me, I sure am tired. Anyone know where I can get a good cup of coffee and possibly an abundance of stickers? Thanks, Galatrack. Delete this part.
That is the word on the street. You may get a sticker or a magnet or two if you order, especially if it's your first order. You're starting to catch on, Mordwan. That's right. You go to brushtail.coffee or you go to brushtailcoffee.com. Maybe you will figure out the classical framework.
Maybe one day.
All right, lads.
I like how Dr. Bennett called Mordwan Morty.
It was cute, wasn't it?
It was fun. All right, I'm going to stop the stream here.